Hello everyone, welcome to Pakistan Polymer Research Forum. This is a virtual forum on polymer research is happening in Pakistan. I welcome you all for this special forum on the polymer research. As you know, this is organized by Technobase. Technobase is an international resource center for the polymer industries and technologies. We have a good lineup of speakers from the Pakistan. They've been conducting extensive research on the polymers. We have both experienced and also young researchers from the universities. So we welcome you all for this program. The schedule, the agenda will be like this. I do a little introduction and also a quick introduction to the Technobase. And I'm very much thankful to my partner, co-organizer, putting this program together. That is Mr. Hamid Iftikhar. He is currently a senior manager in the compounding section at the Panther Tire Limited in Pakistan. And we have speakers from the University of Engineering and Technology, Lahore, okay, and also from the Samad Rubber Industries. And we have also the National Textile University from Pakistan. So you see, we have quite a number of polymer research topics are here. We will be addressing one by one. I don't want to fix the schedule in like 20 minutes or 10 minutes like this, because the time varies, depends on the topic. But it will start, it will maybe 2.5 hours to 3 hours long altogether. Yeah. And at the end of this presentation, we have a Q&A session. Let me quickly tell you about Q&A session format. After each presentation, we will not address the questions immediately, but we collect all the questions and we address it at the end of all the presentations. So feel free to post your questions, submit your questions on each presentation in the question box. And these questions we address in the Q&A session, which will be at the end of all the presentation. That is a format of this Polymer Research Forum. Okay. Let me give you a quick introduction to Technobase. Probably some of you know already about Technobase, but I give you a quick introduction. Technobase, as I mentioned to you, it is an international resource center for industries and technologies. What do you mean by resource center? It's a resource center. We offer services that benefits industry professionals. Our services are global services. We organize exhibitions, and we have training and conferences. We have webinars. We have business networks. We have publications, and we also do the talent search, knowledge test, consulting, and business matching. These are the services. Every service is connected to the 3 components: education, business, and networking. So the foundation has always been education. And with education foundation, we connect business people, and also give the networking option also. The segments we cover is mostly the polymer segment in the rubber industry, plastics, polyurethane, and also the adhesives and coatings. But we also on the process technologies, focusing on chemical engineering and technology, energy, environmental, water and membrane technology, filtration, separation, things like that. So we cover a broad range of industry segments. But it covers everything about knowledge, business, opportunities, and the networking. When it comes to the virtual events that we organize, Technobase organize, we have actually 4 types of virtual events. What you are joining today is basically a research webinar. And we actually, under research webinar, we promote research happening in particular segment. So we are addressing today on the Pakistan polymer research, basically what kind of research is happening in Pakistan. But we also have a know-how webinars, which is a basically educational platform, or it's like online training program on specialized subject. Of course, we have in plastics, rubber, and polyurethanes, and also membrane technologies. A lot of topics available. You can check the website know-how-webinars.com. And we do have this technology webinar, which is basically promoting introducing the techno-commercial presentations. Industries, technology suppliers offer the latest technologies. We through these technology webinars, we offer in various webinars and forums, promoting the technical presentations from the supplier point of view. And we do have eminent personality webinars, which is basically about it's all about the journey of the professionals, well-respected people in industry with a long experience, eminent people, who are usually the more than 70+ years old with a long experience. We talk about their journey, what kind of experience they gained, and what kind of lessons they learned. So We have 4 types of virtual events. I do request all of you to have a look at the knowhow-webinars.com, technology-webinars.com, research-webinar.com, and also even Panelists for more information. You may find some of them are useful to you as well. Okay? Many of the programs, some of which are from publicized to the public domain, we post in our Technobi channel in YouTube. You can also view this webinar, today's program, Polymer Research Forum, Pakistan Polymer Research Forum. This will be available in the YouTube as well. Okay, so if you're not joining the live session, you have a chance to view it in our Technobi channel and through the YouTube. Okay, that's briefly about Technobis. You can always check our website, technobis.org. And if you have any questions, like inquiries, you can always write to me at param.technobis@gmail.com. Okay, that's a brief about Technobis. Now I welcome my partner and coordinator for this Pakistan Polymer Research Forum. This is our first edition. When I asked Hamid to support me, he immediately say yes. And currently he is working as senior manager in the Department of Compounding and Tube Division at the Panther Tires Limited in Pakistan. Hamid, I welcome you to share, give you the welcome remarks. Please open your webcam and also the speaker, please. Thank you.
Hello, everyone. Myself, Hamid Iftihar, as Pam already gave you my introduction. So I'm very pleased to be the part of this one-of-a-kind event that is being happening in Pakistan, and thanks to Pam for generating this idea, and he then approached me for that, and I showed my willingness to be the part of it as a coordinator, just to promote the polymer research activities in Pakistan. And I'm very happy to be the part of this event, and I hope to carry this forward, and next time to see more and more participants and presenters, so that our work here in polymer research field in Pakistan is promoted to other people internationally, and they can gain benefit from our working. So as Pam told you, this event is titled as Pakistan Polymer Research Forum. Different presenters from the universities and industries will present their research work here, and I hope you people can get benefit from this, and more and more people will be available with us for the next event we are planning, which Param will share with you the future planning of the Pakistan Polymer Research Forum. About the panelists and the presenters, Param has already given an introduction to you. They are from various universities of Pakistan, from their polymer departments, and some of the participants are from the industries, which are working at technical positions in the industries. I myself am working as senior manager compounding, rubber compounding, basically in one of the leading tire and inner tubes manufacturing companies of Pakistan, namely Panther Tires Limited. So we all are involved in research work in one way or another, either in university or in industry. So I hope the presentation today will be beneficial for you in terms of gaining insight into the polymer research field and some other aspects. So I guess without taking any more time of yours, I'll ask Param to start the presentation work. And Param, please give the introduction of the first presenter, and let's start the presentation work.
Thank you, Hamid. Again, my sincere thanks to you being part of this one, initiate, supporting this journey. And it's just a beginning, I say. We will explore and more on the polymer research is happening in the Pakistan. Okay, let's get to as you mentioned, let's get to the point of what we are here for. It's on the technical session today. We have various presenters. We'll address one by one. And the first presenter is Dr. Xrd Qayyum. He is an assistant professor at the University of Engineering and Technology, Lahore in Pakistan. He will be presenting on the role of nanofillers in upcycling of polymer waste. Let me repeat this title. The role of nanofillers in upcycling of polymer waste. Dr. Xrd Qayyum, please start your presentation. Let me ask you to share your screen. Yeah.
Hello everyone, my name is Dr. Yasir Yungil. I'm working as an assistant professor in the Department of Polymer and Process Engineering in University of Engineering and Technology, Lahore, Pakistan. The topic of my presentation today is role of nanofillers in upcycling of polymer waste. The contents of my presentation are going to be upcycling concept of plastic waste, introduction to nanofillers, their types, upcycled polymer nanocomposites, what are they, what are the various methods that can be used for incorporating nanofillers in plastics. Previous work that I have done within this field, I will be discussing two of my research papers due to time limitations. There are a number of research papers that I have already published along with conference papers, but these are the two that I think are more relevant today to today's discussion. Then I would like to, in the end, discuss what will be the primary objective to take this research further ahead, and finally the references and any of the question answer sessions. Now, upcycling concept of plastic waste.
Excuse me, Dr. Yasir, can you put on a presentation mode, please, your slides?
Okay.
Okay, continue, please. Thank you.
Upcycling concept of plastic waste. Now, everybody knows that there is a huge quantity of waste polymer that is being generated from the various sectors of life in which human beings throughout the world. It is not related to a specific area of the world. For example, you can blame Asia or you can blame Europe. It is throughout the world. And these sectors are industrial, household, and agriculture. Today, they account for 12% of the municipal waste in contrast to only 1% in 1960. And this ratio or this percentage can vary depending upon the areas, but roughly they account for 12%. Now, one of the options that the world has utilized in the past and is still being utilized is mechanical recycling of plastic waste. Apart from mechanical recycling, we can either go for our landfill option, or we can go for incineration or pyrolysis. Now, these three areas, the recycling through mechanical means or through incineration or pyrolysis, they do offer some advantages, but more or less they develop through them, the products that we are developing, they are not of high value, and landfill obviously is not a very good option anywhere in the world. Now, the option that we are going to be discussing today, and which is of prime importance when it comes to deutilization of polymer, in order to make sure that we incorporate the polymers through recycling in our daily life, is through mechanical means. Now, during mechanical recycling, what happens is that a lot of heat and mechanical stresses are being applied on the polymer, as a result of which it causes a destruction in the morphology or the structure of the polymer, and this then later on affects the mechanical, chemical, and thermal properties of the polymer. So actually what we are doing through mechanical recycling is we are trying to produce products that don't have superior properties, or rather they have deteriorated properties. So based upon that, you can say that we are basically trying to, through mechanical recycling, produce product that will not have the desired properties of a high value item. Now, what we can do in order to make sure that through recycling, we can also improve these properties. Now, to improve these properties, one of the methods that has now been in use since the last 30 years and have proven to be very effective in increasing or enhancing the properties of polymer is through the utilization of organic and inorganic nanofillers that can then lift up the properties of the polymer. So as a result of which, if we are able to incorporate our nanofillers into polymers, then we can move towards upcycling. So before we move along, you can say that there are three ways in which polymers can be reused. One of them is conventional recycling, just try to maintain the properties at the same level. Another option is downcycling, where we are mostly moving in in at the present time where we are deteriorating its properties. And the third option is upcycling, so that you can enhance its properties that would then widen its application range. So you can then incorporate that material with enhanced properties in a number of other areas. Now, our primary goal in producing polymers with enhanced properties through upcycling will be the utilization of nanofillers. Now, the accepted description, or you can say the definition of nanofillers or nanoparticles, is that they must have at least one dimension in the range of 1 to 100 nanometer, and the other should be in the range that are greater than 100 nanometer. Based upon these, we are able to classify them into three basic categories: one-dimensional, two-dimensional, and three-dimensional nanofillers. One-dimensional nanofillers have one of their dimensions less than 100 nanometer. Two-dimensional have two dimensions less than 100 nanometer, and three-dimensional particle nanofillers, the calcium carbonate and other types, they are relatively equiaxed particle with all three dimensions in the nanometer ranges. Now, the classes of nanofillers can also be described on the basis of their origin. For example, we can have the nanoclays, we can then have the organic and inorganic nanofillers, or we can have the carbonaceous nanostructure or carbon-based nanostructure. The most famous one are your carbon nanotubes, which are being utilized everywhere. Now, what we are going to do with these nanofillers, we know about them, but what we are going to do with these nanofillers? The most important point is we have to make sure that their nano size is retained. We have a narrow particle size distribution and a higher surface area. And we try to make sure that they are as pure as possible without including too much surface modification. If we try to incorporate these categories of nanofillers into our polymers, we will then get improved properties. Now, there are various nanofillers that you will encounter in the market. Those could be present in the form of a nanoparticle, in the form of a nanorods or nanoplatelets. But when the industry try to utilize them in their polymers, okay, what they end up seeing through a scanning electron microscope or through a transmission electron microscope are rather their aggregates, or in sometimes they also observe assembly of aggregates where different aggregates are combined together to produce a structure which is not reminiscent of a nanoparticle. So then they ask the question that we added nanoparticles into our polymer or a nanorod material. Why can't we visualize it with the help of microscope? Because the overall structure is present in the form of agglomerates or in the form of aggregates. So our goal is to make sure that once we incorporate the nanofillers within our polymers, we get the least amount of aggregates or the assembly of aggregates or the agglomerates as they are known as. Unfortunately, we cannot eliminate them, especially once we try to move towards higher weight percentages. One of the points that is now being realized by the scientists throughout the world is that if we try to incorporate more and more nanofillers or higher weight percentage of them, then aggregates form in quite large quantities. So what we can do in upcycled polymer nanocomposites is try to incorporate these nanofillers into our waste polymer and make sure that they remain separated. The aggregates don't form. This is what our basic requirement is for any method that is being used. It should ensure that, and this is what the goal of this research is. Now, the various methods, most of you would know about them, that can be used for incorporating nanofillers in plastic. These include your melt blending, in situ polymerization, and chemical method. Now, the most effective method in terms of production value is the melt blending, because through melt blending, we can use various techniques such as extrusion, injection molding, and other thermal processing methods to make sure that our nanofillers get incorporated within our polymers, and we get enhanced dispersion and distribution of the nanofiller along with the removal of agglomerates or aggregates or assembly of aggregates. If we are able to ensure that, then those polymer properties will be enhanced by the addition of nanofillers. So by keeping in mind this concept, a number of research work has been carried out within our Department of Polymer and Process Engineering, and I have also carried out this research during my PhD in Department of Materials in Loughborough University. And I would like to discuss a few of those research with you, that how by utilizing these various types of fillers, we were able to enhance the properties of the polymer. Now, the first such research is comparative study of carbon-based nanofiller for improving the properties of HDPE for potential applications in food tray packaging. Most of the time, the products that we are trying to develop are the one in which we would like to develop the products that are in demand in the market, and nothing is more in demand in the market than packaging. Everybody needs packaging, and my second talk is on that point, and so we'll continue about packaging in that area. This research was published in Polymers and Polymer Composites. So what did we do in this research? HDPE was blended by a specialized technique with various carbon fillers to produce various composites that included the incorporation of multi-wall carbon nanotubes, graphene oxide, and carbon black on a twin screw extruder. The morphology was characterized, and then it was correlated to the mechanical, thermal, and barrier properties. And the results basically showed us that there was a distinct effect of carbon black on mechanical, thermal, and barrier properties of HDPE in comparison to multi-wall carbon nanotube and graphene oxide. This is the SEM picture in which you can see very few agglomerates have formed, and a uniform dispersion and distribution of the carbon black, the graphene, and multi-wall carbon nanotube is visible to you from the scanning electron, from the field emission gun scanning electron microscope results. We started doing the mechanical characterization of these specimens and the impact properties showed an enhancement in the properties of carbon black based material in comparison to the other materials that we incorporated. So this basically gave us a heads up that, okay, these materials can be incorporated to produce polymers with enhanced properties. The mechanical characterization showed same results. Carbon black gave us superior properties in comparison to the carbon nanotubes and the graphene nanoplatelets. We also did the water vapor transmission data and the oxygen transmission data, and once again in this the results were not inconsistent with the results that we attained previously, because in this case the role was played by the platelet structure of the material under consideration. So, and the type of morphology does the nanofiller have. So in this case, carbon nanotube gave better properties in comparison to the graphene and carbon black based particles. Now, in another research carried out in this in the field was development of HDPE composite with improved mechanical properties using calcium carbonate and nanoclay. Now, in this research, we utilized calcium carbonate and nanoclay to reinforce our materials. The effect of fillers on tensile strength, toughness, impact strength, and other properties was carried out, and we found out that Young's modulus was increased up to 22.5% for the ternary nanocomposite that we developed in the combination of calcium carbonate and nanoclay and HDPE. And later on, we then looked at the tensile strength, and we did found enhancement in those properties. Now here you can see 100% HDPE was compared with 95:5 calcium carbonate based specimen and 92:5:3 weight percentage of HDPE, calcium carbonate, and nanoclay. Uniform dispersion was once again achieved, and we did saw enhancement in the properties by the incorporation of calcium carbonate in the mechanical characterization. The same sort of results were obtained for tensile strength, toughness, and Young's modulus. So what is our primary objective of carrying out all of these researches is to make sure that we are able to incorporate these nanofillers into polymer waste such as HDPE, high density polyethylene, polypropylene, polystyrene, polyethylene terephthalate, polymethyl methacrylate, polyvinyl chloride, and then try to enhance their mechanical, thermal, optical, and barrier properties depending upon our requirement. And what is the primary requirement? Where all of these recycled material will go? that will be one of the starting point could be the automotive products. We can take the waste. This is polypropylene waste, the mask that we are all using on a daily basis. This waste can be enhanced by using nanofillers to produce various products that are then supposed to be used in the automotive area. And my own MSc student, Mr. Mudassar Khurshid, is working on this area with Grand Engineering Private Limited, which is one of our sponsors for this research, and they also produce quite a lot of automotive parts. So this is what a brief summary of the work that we have done in this field is, and these are a few of the references that we have used. So thank you for listening to me for my presentation. If you have any question, you can ask.
Thank you very much, Dr. Xrd. Let me take over the screen. Guys, if you have any questions on this presentation, I do request you to post your questions in the question box. We address the questions at the end of all the presentation. Okay, when you write your question, please do mention the speaker name. Now the presenter his name is Dr. Xrd. So Dr. Xrd, and post your question so that at the end of the presentation in the Q&A session, that speaker will address the question appropriately. Okay. Now, as Dr. Xrd mentioned, the next topic also will be presenting by him, and the topic is focusing on the mono-material, multi-layer, and upcyclable smart packaging for propelling the circular plastic economy. Dr. Xrd, please share your screen again. Here we go.
Okay, hello everyone. This is my second presentation. I have already introduced myself. Now the topic of my second presentation is going to be monomaterial, multi-layer, and upcyclable smart packaging for propelling the circular plastic economy. The contents of my presentation are going to be introduction, sustainable packaging trends in 2019, sustainable packaging trends in 2020, importance of packaging selection, oil pouch recycling, where I will introduce to you the details of my research work that is being carried out in this area. Then we'll look at some of the packaging options that can be adopted, and finally we will look at some case studies. Now the consumer packaging option for the future are expected to be high performance, upcyclable, multi-use, and one of the basic requirements that is still here is that they should be lightweight products. Now, one of the keywords that you should take away from this discussion is that the product has to be upcyclable and multi-use and high performance. So there are multiple requirements from a packaging. You can't just throw away your packaging after single use. You have to ensure that it can be converted into useful product, and you as a consumer can play a huge role by making sure that you recycle properly, and then it should be up to the industry to upcycle that product. So this is the point that the viewers should understand. Your role is recycling. Industry's role is to upcycle. You should make sure that the packaging that you are using on a daily basis, it should be collected properly, and then it should reach the right kind of industry that can then upcycle it. In an ideal world, it should be the same company that has manufactured that product. Now, the options that we have at the moment in terms of packaging are all based upon multi-layer structures. These multi-layer structures basically consist of biaxially oriented polypropylene, polyethylene terephthalate, high-density polyethylene, polypropylene, oriented polypropylene, metallized oriented polypropylene structures. You can name them. There is a long list of polymers that are now being used in layered structure, in which different layers are joined together depending upon their repeating unit. You can either join them through heat, or you have to use sometimes a adhesive. Now, we don't stop at that point where we join the various layers together. Why we join the various layers together? So that we can get the benefit of each property that the polymer can offer in an economical way. That is of our prime importance for requirement for joining the various polymers together. But we don't stop at that point. We then try to deposit aluminum on the inside of that packaging. We then, for marketing reasons, we try to put printing on the outside of the packaging. Okay, so that complicates the overall packaging system that we use. It is a very good packaging system. It is an excellent system in order to enhance the shelf life and to sell your product. But when it comes to recycling, there are quite a number of problems that we are facing. Now, the biggest challenges that are being faced due to multi-layer packaging films are based upon the multiple components that we are using, and this causes a huge difficulty in recycle. We cannot recycle it in its own, on its own. Obviously you can put it in an extruder, but the product that is going to come out, it can't be used for in the areas where higher performances are required, because we have combination of polymers that are not compatible with one another. We have the presence of inks that were used for printing. We have the presence of adhesive. We have the presence of vapor deposited aluminum that is there. So as a result of which, we then have to separate each and individual layer together, each and individual layers, and then make sure that we then can recycle them individually. So that creates a huge problem. There are various groups that are now trying to develop products that can eliminate these sort of hurdles that are there. And obviously, if you are using multi-layer structure, your production is going to be very high. Very high. So these groups are basically now trying to see what can be the option that can now be adopted. Now, one of the options that can now be adopted is to eliminate the multi-material multi-layer structure. We're not talking about eliminating the multi-layer structure. Multi-layer structure can still exist. You can have a mono-material based multi-layer structure in which each and every layer will consist of the same polymer, but there will be difference. Some of the layers will have their properties altered by the addition of nanofiller, as a result of which we can try to reach the same sort of properties that are being offered in the various packaging sectors by multi-layer structures of multi-material that basically consist of multi-materials. So this can now be an area in which the researchers can start to work. And in the past 10 years, this has now gained quite a lot of, this area has gained quite a lot of attraction, and people are now talking about it on various forums, and various experts in this field are now trying to consider that what can be the property ranges that we can cover by using monomaterial. And what properties are we looking for? We are looking for good barrier properties, good antimicrobial performance, and good mechanical performance. And it is also expected that if the monomaterial properties are enhanced, it can reach an area, it can reach a value. This whole monomaterial based industry can reach an estimated amount of $71 billion in 2025. So what are the various areas, or what are the various trends in which the experts are talking about in terms of sustainable packaging? In 2019, it was the primary trend was to make sure that you design a packaging so that it can be recycled and it can be reused. Then next one was replace the plastics with bioplastic or paper and try to remove the packaging. Then at number 6 came the point of you try to move towards monomaterial. You ensure that monomaterials are being used. Another option that the industry has now adopted quite a lot, you will now start seeing these trends in your shampoo bottles, where you will see that we have that the company would write it down on the shampoo bottle that their bottle contains 70% of recycled content. Another company would say our bottle contains 80% of recycled content. So more and more products are now being reused in the packaging, and the rest of the two are customer is the key, and new out of the box ideas should be adopted. So in 2020, the trends for sustainable packaging would then recognize the utilization of monomaterial or single layer plastic, even single layer plastic, as the most primary or important trend that is now being adopted. Okay, that we have to move towards monomaterial. Multi-layer, multi-material based structures are very good. They are excellent. There is nothing that we have against them, but their recycling causes quite a huge hurdle. And in order to solve them, we need to then alter them and replace them. Reducing the plastic components altogether, that was also one of the packaging trends. Then the same one was repeated: reuse, utilization, replacement with bioplastics and biopaper. With regards to bioplastic, you do need to realize that they have a huge problem with regards to their price. Okay, their price is too much high, even up to now. In Pakistan, the minimum that you can get is 800 to 900, and even those materials don't have the desired quality. Good quality biopolymers, PLA, PBAT, PBS, they start at 1200 or even higher prices per kg. Prices are there in the market. So bioplastics, although a good option, but at the moment they can't directly replace the multi-layer structures. Other packaging trends were increasing the utilization of recycling material, using the material having less carbon footprint, and trying to adopt the circular economy and making sure we get good bioplastics from wood-based material. So before we move along, why we are talking about this multi-layer structure, and why I have reiterated this point again and again, that these are excellent material. You can see this table in which a clear LDPE pouch has an oxygen transmission rate of 38.3. Now that value would reduce quite a lot. From 38.3, we will move to 0.9 for clear LDPE, but that has polyamide or nylon present in between the LDPE layers, along with the tie layers. Obviously, the tie layers are going to be there, but that enhancement in the overall barrier properties of LDPE is why we move towards multi-material based multi-layer structures. LDPE along with the tie layer and nylon can give you enhanced properties in terms of barrier characteristics, and those are required by the industry, because that will then increase the shelf life. The higher the shelf life, the more chances you have your product will be bought by any consumer. So keeping in mind this area, we then started working in trying to recycle these multi-layered structures, but we then ran into some problems. What were those? We took the oil pouch, the one example is shown to you over here. The internal morphological structure basically consists of LLDPE with a tie layer, which is basically LLDP grafted maleic anhydride, which is used as a compatibilizer in polymer and also as a tie layer. Then it has nylon present in between them, and the weight percentages are shown to you over here. When we try to process these material through thermoplastic processing using extrusion, we found out through scanning electron microscopy results that there was clear phase separation between the nylon and the LLDP. Then we tried to enhance this through various compatibilization technique, and this research is still being conducted, so that is why I have not included the result. But just to show you that these are the problems that you will end up if you try to recycle these multi-layered structures directly. You then have to make sure that you incorporate some other modification techniques in terms of compatibilizers, in terms of chemical modification, to get the desired results. Okay, so the recycling of multi-layered structures on its own is not a good option. So what we can do with these multi-layered structures, we then have to separate them out. Separating is another problem on its own. If you try to separate them out, you then have to first of all remove the internal vapor deposited aluminum layer. You then have to separate out the adhesive. You then have to remove the ink. Then you end up with a lot of junk material or a waste material on its own. And from there, you will be able to recover the HDPE layer, polyethylene terephthalate layer, and biaxially oriented polypropylene layer, or simply oriented polypropylene layer. So then it becomes a huge challenge for us. So what are the options that we can adopt? If these are the problems, we can adopt a single layer printed packaging, okay, or multi-layer monomaterial printed packaging. But even then, with in terms of recycling, this will still cause a problem. Or we can move towards a single layer non-printed barcode packaging. This is what our group is trying to now suggest, that remove all the printing. If we remove the printing, we can use the barcodes, and then that can be very good effectively. Or we can use the same multi-layer structure, but you need to down gauge them. So in what direction we are moving in within this Department of Polymer Process Engineering, we are trying to adopt the technique through which we can develop multi-layer monomaterial based structures, okay, or single layer structures that will have enhanced properties. And one of the route that can be adopted in enhancing the properties of polymers so that they can meet all the requirement is by the utilization of various nanofillers. So polymer nanocomposites can be adopted, and they can be used to enhance the properties. These include our clays, graphene, silicates, and as a result of them, we always try to enhance the barrier performance against water, oxygen, and carbon dioxide. And we try to achieve these properties by making sure that we get a good tortuosity path created within the polymer by the addition of nanofiller. We get enhanced dispersion and distribution of the nanofiller, and we try to eliminate or restrict any of the agglomerates. Now within this, I have worked in this area in the past, and I am still working in this area. And one of the case studies, the permeation characterization and modeling of polyethylene clay nanocomposites for packaging. It was published in Polymer Bulletin. Now in this area, we basically utilized the kaolin clay and sodium MMT clay to enhance the overall properties of HDPE so that it can then be utilized in the industry. Once again, a specialized technique was utilized for pre-blending the nanofillers with polymers without using any compatibilizer. No compatibilizer has been used in any of the case studies that I have discussed. We try to enhance the properties by using specialized pre-blending techniques, and then we try to utilize the extrusion technique to make sure we get materials with good dispersion and distribution of nanofillers and try to remove as much agglomerates as possible. These were the formulations that we utilized, and we try to vary them, the presence of clay from 1 to 10% for the materials under consideration. Now, one of the first analysis that is done in the analysis of nanocomposites, or in characterizing the nanocomposites, is Xrd analysis. And from here, you can see, due to the internal structure of kaolin clay, it becomes really difficult for us to separate the individual layers. But sodium MMT clay can be differentiated. So based upon these initial results, we were then able to compare what would happen if our material is fully exfoliated. Then what sort of properties we can expect, and if it is not exfoliated, then just by utilizing the pre-blending techniques, up to what extent we can get enhanced properties. There are other options of intercalation or macro composites that can be studied based upon these initial results. Now the TEM results, it showed good dispersion and distribution, but it also showed the presence of few agglomerates, but most of the time the tortuosity path was there, and along with the tortuosity path, the good dispersion and distribution of nanofillers within our material was present. We then tried to look at the overall aspect ratio calculations by utilizing the TEM results along with ImageJ to see what was the aspect ratio, and we found out that we were able to get good aspect ratio. Now, one of the things that you need to understand is that in terms of kaolin, we were not able to separate them out individual layers, but there was a combination of layers that was present in the form of an aggregate, These aspect ratio basically represents the overall dimensions of those aggregates. SEM results also showed us good dispersion and distribution, and only for very high weight percentage we were able to then get few agglomerates and few phase separation present within our material. WVTR analysis, or the water vapor transmission rate, which is of prime importance, gave us good deduction in the properties and showed us that if we try to incorporate up to 5-8%, then the water vapor transmission rate will decrease. The same was true for oxygen transmission rate. Along with these properties, we also analyzed the internal morphology by utilizing the polarized optical microscopy, and it showed a reduction in the overall size of the spherulites by incorporating various nanofillers. So in terms of summary, we were able to get good reduction in the WVTR and O2TR by utilizing up to 5-8%. As we move toward 10-8%, the properties started to, the enhancements started to deteriorate, and we then found out that this is the range up to which we can expect good results in terms of the barrier properties and also in terms of internal morphology of the polymer. Now, another work that has been done by myself in this area is for the high performance graphene nylon nanocomposites. In this area, we were able to develop nylon 11 and nylon 12 functionalized graphene nanocomposites to see what sort of effect would it have on the ultimate tensile strength, elongation at break, impact strength, toughness, permeation resistance, by incorporating as lower amount of functionalized graphene as possible. Here you can see very good dispersion and distribution of the individual graphene layers that we were able to separate out. You can see a few of the agglomerates. This thing you need to keep in mind that the individual layers will separate out, but few agglomerates will always. So we are always trying to restrict their amount. We cannot eliminate them. The water permeability, once again, even both for nylon 11 and nylon 12 showed good properties even at very low weight percentages of both the material. The same was true for oxygen transmission rate analysis. So based upon these results, what we can conclude is that if we are able to use monomaterial based upon the two case studies that we have just discussed, and if we are able to then combine the monomaterials with the various nanofillers added into them to produce multi-layered structures, those would then be upcyclable. Okay, because of the presence of nanofillers, we have already established the fact that if nanofillers are present and you get good dispersion and distribution, and you're able to enhance the overall dispersion and distribution and enhance and make sure you get good interaction between the polymer and the nanofiller, you will be able to get good upcyclable material. And finally, based upon the various requirements of the future, we can then incorporate various functionalities into our polymer to get materials that are much more smart. Okay, that's all from my point of view for this presentation. If you have any questions, you can type it in.
Thank you very much, Dr. Xrd. As Dr. Xrd mentioned, guys, if you have any questions, I'd repeat this slide again on this topic. Please post your questions in the question box, and please mention the Dr. Xrd name before you start typing the question, so that we address this question at the end in the Q&A session at the end of all the presentations. Before I proceed to the next presentation, maybe I'd like to ask a few questions to Dr. Xrd first, because many of the presentations are from his university. Dr. Xrd, is it possible for you to share some light and give us some background information on your university? What kind of research is happening? What kind of facilities you have, kind of intro for your university and department. Yeah, please. Okay. Thank you.
Okay. Our department was established in 2002 in University of Engineering and Technology. Earlier on, it was basically the degree was offered by the Department of Chemical Engineering, but later on in 2006, it was separated. The degree program was separated into an independent department, and from there onward, we have been working as an independent department in University of Engineering and Technology, Lahore. We have a number of research facilities that are available for our students and for the students of the department and for the students within UT Lahore. Apart from that, we do get various requests from students of all the universities of Pakistan. Even just 2 days ago, I got a request from Quetta, and Quetta is very far away from Lahore, that even they wanted to use our facilities. So just to give you an idea, we do have the state-of-the-art machinery available in terms of characterization and testing of material. We have universal testing machine, we have differential scanning calorimeter, we have thermogravimetric analyzer, we have Fourier transform infrared spectroscopy analyzer available, we have the dynamic mechanical thermal analyzer available, we do have UV vis spectrophotometer, melt flow indexer, rheometer. So most of the materials that are basically used to test and characterize the material for any area of research, we do have those facilities available within our department. Apart from these testing and characterization, we do have our internal mixers available within the department. We have extruders, we have injection molding machines, we have a state-of-the-art structure and synthesis lab to synthesize the polymers. So any area where you can think of, we have it covered. We do have our a rubber lab available with us, where we have a two-roll mill, a compression molding machine, MDR is available. So most of the topics that are covered within the scope of polymer engineering, we have it covered both in terms of theory and in terms of practical sessions for the various laboratory exercises. In terms of the research group, we have research groups, basically one of the largest research group in terms of polymeric membrane is working within this department. We also have a research group that is working in polymer composites. And apart from that, I'm working along with Dr. Farhan Said, and now Dr. Farooq has also joined us. We three are working in the area of polymer processing and elastomer processing to develop solutions for the packaging industry and automotive industry and the electronic industry. Now, and there is another group that is working in the development of solutions for the energy solutions. That is they are working in the field of solar energy, and they are mostly they are working in the development of dye sensitized solar cells. So these are few of the research groups that are working within our department. We are working in collaboration with a number of departments within UT and outside UT, and also we are working in collaboration with other industries too. For example, last year I worked with Angro for Angro Polymers, the utilization of a PVC in the development of wood polymer composites. So we have all the facilities within our department, and research collaborators or students who want to work with us, they are always welcome.
Nice. Thank you very much for sharing the insight about your department. It looks so you guys are very active in the polymer industry research. Yeah. And you also mentioned you also in Pakistan. Usually the research happens by support from the government, and also industry itself also ask you to and give you some kind of contract research as well. What it is like?
We get support from our university and from the Higher Education Commission and from the Higher Education Department to do work, to do research work. But now we are moving more towards university industry linkages, so that we can develop these linkages and then try to develop solutions for the industry. I just mentioned to you that my first talk, the role of nanofillers, it is being partially sponsored by Xrd Engineering Private Limited, which is a large automotive manufacturing unit in Lahore, and they are providing us few of the initial support, not very large support, but at least we have them on board now. Some of the local industries and also international the renowned local Pakistan industries are also now coming to us, and we are working with them to develop various solutions. And along with that, we do apply for funding from the government resources, and a number of our research along with me have also research funding available to us for the students to come and work with us, or we then try to link them with the industry.
Yeah. And also your university, also international organization or universities, also some kind of collaboration between overseas universities too.
Yeah, we some of my colleagues are also working in collaboration with other universities. Most of them are in link with their supervisors working in that area. We have some links in Saudi Arabia and Dubai where we try to collaborate our research with them over there. So we do have these collaborations too.
That's nice. Yeah, thank you very much, because you know, it's important that people should understand not only what research you do, what kind of facilities are in there, and you know, anybody, any audience would be interested to collaborate with you, you know, take your assistance in developing solution for the problems, you know. So okay, thank you very much for sharing that. Let me move to the next the part of the program. We have a next presentation is on the process optimization of cross-linked polyolefin closed cell forms based on compression molding. And this presentation has been given by Mr. Muhammad Asir. He is actually working as R&D manager at the Samad Rubber Works Private Limited in Pakistan. Let me open his presentation. Please stand by.
Hi, good evening everyone. First of all, I would like to pay my thanks to Mr. Hamid Iftihar and Mr. Param from Technobiz for providing me this opportunity to present my work on this platform. Today's topic of my presentation is process optimization of cross-linked polyolefin forms based on compression molding. To begin with, I would like to share a bit about myself. I graduated back into 2014 from National Textile University, Faisalabad in Polymer Engineering. After graduation, I joined Samad Rubber Works as a management trainee officer in Research and Development Department. Currently, I'm working as Manager of Research and Development in the same organization. If I talk about my organization, we have 5 business segments, which includes adhesives, foams, technical textiles, apparel, and medical PPEs. And I'm looking for the research and development of mainly foams and adhesives, and also for technical textiles and medical PPEs. To begin with, I would like to share the content of my presentation, which includes polymeric forms. Will be a bit introduction about the polymeric forms and then forming processes. Then I'll talk about the optimization of polymeric forms processes in general. Then I'll go into the details of the rheology and the solubility and diffusivity parameters. Then I'll come to the polyolefin forms and their properties, ingredients for polyolefin forms, which include polymer, blowing agent, and cross-linking agent. And then I'll go into the details of blowing agents for polyolefin forms, the cross-linkers for polyolefin forms, and the forming process specific to polyolefin forms. Then at the last, I'll talk about the compression molding processes and the optimization parameters involved in the process. Okay, so starting from polymeric forms. Polymeric forms are polymers that contain cells dispersed throughout the polymer matrix. And use of polymeric forms in today's technology continues to grow at a rapid pace throughout the world. Well, there are numerous reasons for such growth, which includes the key properties of polymeric forms, including lightweight, excellent strength to weight ratio, superior insulating abilities, energy absorbing performances, including shock, vibration, and sound, and comfort feature of polymeric forms. According to the marketresearch.com, the global polymeric foam market size is expected to reach $153.8 billion by 2027 at a compound annual growth rate of 3.8%, while the global polyolefin foam market is expected to reach $12.53 billion by 2027, growing at a CAGR of 7.2% from 2020 to 2027. This data has been taken from marketresearch.com. So, in continuation to the introduction of polymeric foams, they can be viewed from different perspectives, which includes their density, cell size, expansion ratio, form morphology, etc., etc. Uh, Speaking individually, if I talk about the density range, they range from 1.6 kilogram per meter cube to over 960 kilogram per meter cube. And if I talk about the expansion ratio, they can be viewed of high density, medium density, low density, and very low density. All have their certain ranges. And if I talk about the form morphology, they are classified as the open cell or the closed cell forms. As an introduction, if I talk about the key applications of polymeric foams, they include packaging, sports, construction, automotive, transportation, insulation, wire cable, etc. So moving ahead with the forming process, most foam polymers are produced by dispersing a gas throughout a fluid polymer phase and stabilizing the resultant. It is a complicated phenomenon which involves thermodynamics, reaction kinetics, melt gas rheology, gas diffusion, and permeation, and others. Forming of polymers can be carried out either by mechanical, chemical, or physical means. Thermal decomposition of flowing agents, generating either nitrogen or carbon dioxide or both by application of heat and pressure. I'll be talking about this process by the way. Secondly, it's volatilization of low boiling liquids within the polymer, incorporation of microspheres into a polymer mass, expansion of gas-filled beads by application of heat, or expansion of these beads in a polymer mass by heat of reaction. Coming to the core of my work, which is optimization of polymeric foam process. Although I'll be talking about the polyolefin forms, but at first I'll be covering the polymeric forms in general. If I convert them into the steps, what steps that we need to follow to optimize any sort of polymeric forming process, for that we can split into 6 steps. The number one is polymer analysis. Whatever the polymer is, it could be EVA, it could be PU, it could be any other polymer. Whatever the polymer is, we have to make an analysis of the polymer to understand what properties that polymer has so that we can get those properties in the end product. And second step is to chemical characterization of chemical blowing agents, cross-linking agents, or other ingredients which are present in a certain formulation. And the next step is rheological investigation, which basically includes the shear viscosity, extensional viscosity, and such factors like that. The next is gas solubility measurement. Number 5 is gas diffusivity measurement. And the last step is cell nucleation and growth study. So to moving with the optimization of polymeric foam process, as I mentioned earlier, we have to follow some certain steps. And I'll not go into the details of polymer analysis and the chemical characterization of different ingredients. I'll be talking about the rheology first of all. Rheology is basically the study of viscosity, which is a measure of resistance of a fluid to flow. This is a very typical definition of rheology, but the rheological properties of polymer are determined by many variables, such as like polymer molecular structure, weight, temperature, pressure, processing history, strain rate, etc. Unlike those of pure solids and Newtonian fluids, the rheological properties of polymers combines both viscous and elastic properties because we all know that polymers are viscoelastic materials. The viscous behavior means the stress that is applied is related to the strain rate, and the elastic behavior means the stress that is applied is related to the strain. Also, viscosity is a measure of rheological properties of a fluid which deforms when applied with stress. Shear viscosity is a viscosity coefficient when shear stress is applied, while the extensional viscosity is the viscosity parameter when extensional stress is applied. The rheological properties have an important influence on the forming process. Like in the foam molding process, the addition and dissolution of a blowing agent gases into the polymer melt have an impact on its rheological behaviors and viscosities, even with a low gas concentration. So whenever a blowing agent is mixed with the polymer, mm, there is a certain rheology involved that can be checked by the addition and dissolution of blowing agents of gases into the polymer melt. Because the melt experiences stress by both shear and extension low extension, the rheological behavior of polymer melt has a significant influence on pressure distribution inside the mold. Same as the pressure distribution will have impacts on the polymer gas distribution and the polymer melt flow. What is more, the viscosity of mold has an impact on the pressure drop of melt through the mold, thereby influencing the nucleation and growth of the bubbles down the line. Because the nucleation density is mostly determined by deep pressure rate in a mold compared to the solubility pressure of supersaturated polymers. If I talk about the bubble growth, it is related to both the pressure difference and the rheological properties of liquid gas matrix. There are different mathematical models available to understand the bubble growth in terms of rheology. Uh, I can name a few, which includes the power law or the Maxwell melt laws and the mass and momentum transfer. People have contributed in this field by calculating different equations, but I'll not go into such details. I'm sharing just the general perspective of rheology. Moving ahead, since the rheological property is closely related to the polymeric forming, it is important to measure the viscoelastic properties of polymer so as to provide a quantity guide to help control polymer forming. Commercial rheometers such as an oscillating rheometer, elongation rheometer, capillary rheometer, and the foam pressure rheometer are widely used to measure the polymer viscosity data. In polymer forming, the melt flow properties are also influenced by blowing agent because the blowing agent can increase the polymer free volume and chain mobility. That's why customized rheometers can also be used to measure the rheological properties of the processes. And I'll be talking about the foam pressure rheometer in my work to measure the rheological properties of polyolefin form process. After rheology, I'll be talking about now solubility and diffusivity measurements. So starting with solubility, basically the foam production involves preparing a single phase. The single phase includes the polymer and the blowing agent solution, followed by the generation of bubbles, also known as cells, triggered by the thermodynamic instability and stabilizing the bubble structure in the common surrounding. This is a generic forming process. So the solubility defines the maximum amount of a gas that can be dissolved in a certain polymer under a certain pressure. In order to generate thermodynamic instability, to trigger the forming, the surrounding pressure has to be lowered beyond the solubility pressure. Therefore, solubility and related information are quite important for the forming process. Also, there are certain mathematical methods available to measure the solubility. I'll not be talking about the details of those methods, which can be provided on request. The next thing is diffusivity. Cell growth is driven by the pressure difference between the cells and its surrounding with the blowing agent diffusion into the cell. So generally, blowing agent with a lower diffusivity has an edge advantage to produce the large expansion forms. So you can see that how important these parameters are, the solubility and diffusivity. Polyolefin forms. So now I'm coming to the core of my work, which is based on the polyolefin forms. Polyolefins are tough, flexible, and resistant to chemical and abrasion. These are their physical properties. They also are thermoplastic polymers which can be recycled. So the most polyolefin forms have a closed cell structure, which makes the form suitable for application where buoyancy is important. That's why they're used in leisure and sports related application. They can also provide a certain amount of resilience, and that's why it's used in the relative applications. So if I talk about the polyolefin forms and the certain polymers that come under the banner of polyolefins, they include the polypropylene, polyethylene, EVA, which is ethyl vinyl acetate. So based on the basic property of the polymer, we can get the same property in the end product also. Now I'm sharing the typical properties of polyolefin forms. You can have a look at the table. Here is a comparison between polypropylene, high density polyethylene, low density polyethylene, linear low density polyethylene, and ethyl vinyl acetate. Every polymer has a unique set of properties associated with it. I mean, if you have to make a foam with a softer feel, then you have to choose ethyl vinyl acetate. If you look at this value, if we talk about the specific gravity, you can make, I mean, between the range you can play anywhere. This is with the amount of blowing agent, you can alter their specific gravities as low as possible or even as high as possible within a certain range. And if you look at the melting point, you will find that the polypropylene has the highest melting point, which means the foam made with the polypropylene will be the harder one. And if we talk about the EVA, which has a kind of mid melting point, then you will see that the foam made with EVA will be of softer feel. And there are the other properties given for just an idea. Ingredients in polyolefin forms. Generally, in polyolefin forms, other than the polymer, the important ingredients includes the blowing and curing agent. I'll go into details of everything, but before that, as I mentioned earlier in optimization, we have to look at the polymer first of all. What kind of the properties that polymer has, and then we have to look at the chemical characterization of the blowing agent, the curing agent, whatever available is. So these are the key ingredients in a certain formulation. There are some other ingredients also important to be present in a certain formulation, like fillers, which can be reinforcing or non-reinforcing. So this is a basic set of ingredients required for any kind of polyolefin forms. So moving ahead with the blowing agents in the polyolefin forms, the most polyolefin forms are manufactured by dispersing a gaseous phase throughout the polymer matrix. This is a generic polymeric forming process. The substance that produces cellular structure in the polymer is defined as a blowing agent. So the gas used for the forming can be classified into two categories based on the mechanism: physical blowing agent and the chemical blowing agents. While choosing a chemical blowing agent, it is very important to consider two things. The first is the decomposition temperature of the chemical blowing agent. It should not be too high. If it is too high, the polymer melt strength is low at the forming temperature. and is not strong enough to maintain the bubble structure. And if it is too low, if the decomposition temperature is too low, the polymer melt is too rigid, which constrains foam expansion. The other issue is the residence of decomposition products and the generated gases from a chemical blowing agent. Commercially, there are different chemical blowing agents are available, which includes the DNPT, which is dinitrosopentotetramethylene, also the ADC, azodicarbonamide, and OBSH, oxybisulfone hydrazide. But we are for polyolefin forms, mostly ADC is used. The next important ingredient after blowing agent is a cross-linking agent. So cross-linking is basically a chemical bond between adjacent polymer chains. For polyolefin elastomers, there exist three main types of cross-linking procedures. Physical cross-linkings by electron or gamma radiation, chemical cross-linking by agents such as peroxides, and silane cross-linking. I'll be talking about peroxide cross-linking. In peroxide cross-linking, free radicals are generated by peroxides. You can have a look at the picture mentioned here, which cleave thermal to produce two oxyradicals. So free radicals are generated over here, and those free radicals contribute to make three-dimensional structure. Generally, the reaction of peroxide decomposition is the first order. Furthermore, the rate parameter is called the half-life time. It's the basic chemistry which describes the time needed for the decomposition of 50% of peroxides. So the selection of proper peroxide is based on its decomposition temperature. Forming process in polyolefin forms. It is almost same as in any other polymeric form process. Yeah, it can be divided into two major classes, which involves the continuous or the batch process. And compression molding that I am concerned with is a batch process. So if I divide into different steps, first of all, polymer and blowing agents are required to be mixed. And then polymer blowing agent solution formation, where you will have to study the rheological properties. And then the bubble nucleation, which means the starts of bubble. And the last step is the cell growth and the stabilization. So you can have a look at the picture below, which explains the whole process: mixing, diffusion, nucleation, and cell growth. This is about compression molding process. Generally speaking, compression molding is a manufacturing process in which three-dimensional shapes are created using heat and pressure. Material is molded and placed in a temperature-controlled cavity, then shaped under pressure via a hydraulic press. Basically, there are two plates, upper and lower. They are heated with a temperature, and then inside the plates there is a mold cavity where the material is placed, and hydraulically the press is closed, and a pressure is applied, and a temperature is given, and a certain time is provided, and products are manufactured through these techniques. Most of the polyolefin forms are manufactured through the same technique. Thank you very much everyone for having me on this. Uh, I am not available live today. For any questions, you can write me on my email address that has been mentioned over here. Thank you very much.
Okay, thank you, Mr. Mohammed Asir. Now, if you have any questions to Mr. Mohammed Asir on this topic, you can post it, or I will pass your questions to Mr. Asir to respond to us later. Yeah. So again, I repeat that you can post your questions there in the question box. Yeah. Okay, now we go to the next presentation topic by Jumar Ahmad. She's a researcher at the University of Engineering and Technology, Lahore, in Pakistan. She will be presenting about the synthesis of multi-walled carbon nanotube. polyolefin composites for the counter electrode of the PT-free dye-sensitized solar cells. Let's invite Mr. Jamal make a presentation. Let me open the file. Please stand by.
Bismillahirrahmanirrahim. I'm Zumar Ahmed from University of Engineering and Technology, Lahore, Department of Polymer and Process Engineering, and today I'm going to present conductive polymer composites with carbon electrodes for the application of platinum-free third-generation dye-synthesized solar cells. The project was done under the supervision of Dr. Umar Mahmood along with Dr. Yasir Qayyum Gill. First of all, I am going to discuss the abstract of this project. In this work, platinum-based counter-electrode were replaced with polythiophene multi-wall carbon nanotubes-based nanocomposite in order to make the cell cost-effective and more efficient. In this work, polythiophene and MWCNT-based nanocomposite was synthesized via in-situ polymerization, whereas after synthesis, the morphological properties and catalytic activity of sample were investigated with the help of scanning electron microscopy, FTIR, cyclic voltammetry, and many more characterization techniques. The synthesized nanocomposite were then served as a catalyst material for the counter electrode of dye-synthesized solar cell module, and solar cell was fabricated, which was investigated via current voltage characterization. Now moving towards the introduction of the project, first of all I would like to discuss that why solar energy. Energy production and use are growing globally. According to the Global Energy Statistical Yearbook, in 2020, world civilization consumes around 17.7 terawatts of energy. Each year, the sun provides about 3 cross 10 raised to power 24 joules of energy in form of solar radiations on Earth. Which means that if technologies are able to convert the solar energy deposited on 0.2% of the land with efficiency of 10%, we will be able to generate 24 terawatts of energy per year. Photovoltaic cells can convert the sunlight directly into electricity. Now I'm going to discuss the advantages of Dsse over conventional solar cells. Dsse belongs to the third generation of solar cells. They are flexible and easy to fabricate. No rigorous energy processings are needed. They can even work in diffuse sunlight, and polymer-based Dsse are cost-effective as compared to the platinum-based cells. Here you can see a typical energy level diagram of Dsse explaining the structure and working mechanism of Dsse. First of all, in blue you can see the substrate. A substrate is highly transparent glass coated with fluorine tin oxide substrate, which provides the path of solar radiations toward the solar active material. Next is semiconductor. The major function of semiconductor is to absorb dye via providing the surface that accepts electron generated from the excited dye. Next, in purple, you can see photosynthesizer, or typically known as dye. The major function of dye is to transfer electron towards the semiconductor's conduction band and absorb solar energy in it. Next is electrolyte. Electrolyte restores the dye to its initial state after it donates electrons to the semiconductor's conduction band, or you can say that the major function of electrolyte is to reduce the dye which is oxidized due to the discharge of electron to its semiconductor. Last is counter electrode. The function of counter electrode is to restore the initial state of electrolyte and accelerate the reduction process of electrolyte which gets oxidized after giving electron to the dye. Now moving further, I would like to discuss that why conductive polymers should be used instead of platinum and applications of Dsses. First of all, discussing about why conductive polymers should be used. First of all, they are readily available at low cost, so they are cost effective, and moreover they are easy to fabricate. Polymer based solar cells are flexible and they can work even in diffuse sunlight with the same efficiency as that they work in bright sunlight. Applications of Dsses on industrial scales are smoke detectors, temperature and pressure sensors, and thermostats, and many more. Talking about the domestic scale applications of DSSs, so they can use in cameras, wristwatches, calculators, lamps, streetlights, and many more. DSSs can also be used in portable devices, smartphones, batteries, building windows, and many more. In short, DSSs can be used everywhere where energy is needed. Now I'm going to tell you about the research objectives of this project. The overall objective of this research work was to develop low-cost and flexible catalyst material for the counter-electrode in dye-synthesized solar cells. The material must show comparable catalytic properties as that of platinum. The second objective was the synthesis of polythiophene multi-wall carbon nanotube-based nanocomposite, and the last but not the least objective of the research project was to fabricate a dye-synthesized solar cell using this nanocomposite as counter-electrode. Now I'm going to discuss the materials required and methods in this project. First of all, I would like to discuss materials for catalyst synthesis. We have used for catalyst synthesis as thiophene monomer, multi-wall carbon nanotubes, chloroform, and iron chloride FeCl3. These all chemicals were brought from Sigma Aldrich. Now I am going to discuss the materials required for fabrication of DSSE. First of all, we have used titanium dioxide paste, FTO glass substrate, N3 rudenizer 535 dye, platinum paste, liquid electrolyte of iodolite Z50, and all these materials were purchased from Solarnix, Switzerland. After materials, I am going to explain the synthesis procedure of nanocomposite based on polythiophene and multi-wall carbon nanotubes. First of all, calculated amount of multi-wall carbon nanotubes was poured in 50 ml chloroform in a round bottom flask, and the mixture was sonicated at room temperature for 30 minutes for the proper dispersion of MWCNTs. After the MWCNTs was dispersed, 1 gram ferric chloride solution was made with 100 ml of chloroform, and then this solution was added to the sonicated solution of MWCNTs. Further sonication was done for 30 minutes for the proper dispersion and oxidation of MWCNTs. After this, 0.5 ml solution of thiophene monomer was made in 25 ml of chloroform and then added dropwise with the help of a butane NWCNT solution along with constant stirring for 24 hours at room temperature. The precipitates obtained after 24 hours was then washed with methanol hydrochloric acid and distilled water and acetone mixture. After the washing with this solution, the black precipitates obtained were dried in vacuum oven at 60 degrees Celsius for 24 hours, and a black powder of synthesized nanocomposite was obtained. Here in this diagram, you can see the complete step-by-step process of synthesis of multi-wall carbon nanotube and polythiophene-based nanocomposite. Moving to the characterization of synthesized nanocomposite, first of all, I would like to discuss the Fdir analysis. The Fdir analysis was done to check whether the chemical bonding of polythiophene with MWCNT has occurred or not. The Fdir showed low intensity peak at 2800 to 3100 per centimeter and showed a peak at 1628 per centimeter, which shows the carbon-hydrogen bond stretching and carbon-carbon double bond stretching. Secondly, the peaks were shown in the range of 1600 to 15 per centimeter, showed the fingerprint region of polythiophene. Peak obtained at 1628 per centimeter and 1510 per centimeter as well shows the asymmetric and symmetric stretching of bonds. Here another sharp peak was obtained at 700 per centimeter, which indicate the presence of thiophene monomer. The scanning electron microscopy characterization was done to study the structure and diffusion of synthesized nanocomposite. The images obtained via SEM showed dispersion of MWCNTs in polythiophene and the structure of nanocomposite obtained from the in situ polymerization. First of all, figure A shows the structure of pure polythiophene where the lumpy rectangular structure of thiophene is formed, whereas the disintegration of polythiophene can also be seen. Figure B explains the structure with 10% NWCNT. Dispersed in polythiophene, the dispersion on NWCNT is achieved to some extent, and we can see the improved morphology of polythiophene as compared to figure A. In figure C, 50% NWCNT polythiophene depicts the dispersion was achieved was not good as obtained in the figure with 20% NWCNT. Morphology obtained was better as compared to all above figures with 20% MWCNT. The images obtained from SEM analysis shows that no individual agglomerates of polythiophene or multi-walled carbon nanotubes are formed, which depicts that multi-walled carbon nanotubes provide the surface for polythiophene for nucleation growth. Moreover, the dispersion of MWCNT improved up to a certain quantity and then decreased. Xrd diffraction analysis of pure polythiophene, pure MWCNT, and polythiophene NWCNT nanocomposite was observed in order to measure the crystallinity of samples. Polythiophene in the pure form shows the diffraction peak in Xrd pattern at about 12 degrees. The broader peak shows the amorphous structure of polymer. The pattern of MWCNT was observed at 24 degrees, which showed a sharp peak, which shows the crystallinity of MWCNT in pure form. Polythiophene and NWCNT composite analysis shows broader peak at about 24.5 degrees. The broader peak is of polythiophene, and other peak, which is characteristic peak of MWCNT, shows the presence of MWCNT in the polythiophene matrix. Peak of MWCNT is observed to be shifted further from 24.5 degrees. This result shows the interaction of NWCNT into the polythiophene matrix. After characterization of nanocomposite, fabrication of Dsse was done. First of all, titanium dioxide paste was deposited on the glass substrate, and the substrate was then sintered in the furnace at 450 degrees Celsius. The substrate was then dipped in the dye solution for 24 hours, and for the counter electrode, the polythiophene and NWCNT paste was deposited on substrate with the help of Dr. Blade method. Both of the electrodes, photoanode and counter electrode, were joined, and liquid electrolyte was injected through dropper or syringe in, and the fabricated cell was obtained, and IV characterization was done. Current voltage characterization of fabricated cells was done with the help of instrumentation shown in the figure, and the light intensity was 100 milliwatt per centimeter square. Under optimal conditions, Dsse with polythiophene and NWCNT shows the power conversion efficiency of 1.608, and the fill factor was 0.264, whereas the platinum-based cell showed the efficiency of 1.067 and the fill factor was 0.125, fabricated under similar conditions. As shown in graph and table, we find that the efficiency of polythiophene and MWCNT based cell was slightly higher than that of the platinum based cell. So the conclusion is that polythiophene and MWCNT based composites are electrochemically stable and possess high catalytic activity. We also conclude that Dsse with polythiophene and NWCNT shows power conversion efficiency slightly higher than that of platinum based Dsse. Moreover, we conclude that polythiophene and NWCNT could be alternate of platinum material for the large scale production of Dsse. That's all from my side. Thank you very much.
Thank you very much, Ms. Duhan Ahmad, for excellent presentation. Guys, if you have any questions on this presentation, as I mentioned, that you can post your questions in the question box and we'll address them at the end of the presentations. Again, please do mention the speaker name to address these questions. Yeah. Okay, let's go to the next presentation. This is by Dr. Sharjil Abid. He is an assistant professor at the National Textile University in Pakistan. He will be presenting on the emerging role of biopolymeric nanofibers in medical and healthcare applications. And let me ask him to start his presentation. Please allow me to open his presentation file.
Assalamu alaikum and good afternoon everyone. First of all, I would like to thank CEO of Technobiz Mr. Piram and Mr. Hamid Iskar from Panther Tiles Limited Pakistan for inviting me here today to talk about the emerging role of biopolymeric nanofibers in medical and healthcare applications. So ladies and gentlemen, students and researchers and persons from industry, my name is Dr. Shajilabad and I am currently working as an assistant professor at National Textile University, Faisalabad. I have completed my PhD last year in 2020 and I have been working with South Korea and National University of Singapore during my research work. First of all, I would like to introduce what are nanofibers. So this is a structure of human hair. So the human hair is normally around 60,000 nanometers in diameter. As compared to human hair, the cotton fibers are only 20,000 nanometers. But the nanofibers are of the range of only 1 to 200 nanometers only. So we can see that there is a huge difference. So we can say that nanofibers are far much smaller than a human hair. Nowadays, these nanofibers are used for various applications. These include environmental protection as well as biomedical and tissue engineering, battery energy, packaging, cosmetics, and many other applications. So they are used as either 1D or 2D materials. So nowadays, even the 3D nanofibers are being fabricated and they are being utilized, especially in biological and tissue engineering applications. Other applications of nanofibers include protective garments as well as drug releasing materials, energy storage devices, solar cell, filtration, and many other applications. So this means they are being utilized in almost every field of life science. So as we have discussed that these nanofibers have got enormous applications. Why? Because there is something important or special with their properties. So talking about the properties of nanofibers, so they are the materials having high surface area to volume ratio and they are very easy to fabricate using for example electrospinning technique. You can try hundreds of polymers depending upon your end application, both natural and synthetic ones, and you have high porosity and interconnected pores. This means you will have a proper gaseous and liquid exchange if you want to, because there are porous structure available, and these materials can mimic the extracellular matrix of our body. So this is very important for biomedical applications. Furthermore, these are the only systems known to have 100% drug encapsulation efficiency. So for a pharmaceutical system, you need to have a maximum amount of drug being entrapped inside your drug delivery system. So these are the only systems with 100% drug loading efficiency, and you can control the drug release if you want slow release, abrupt release, or sustained release, whatever you want, by the selection of polymers. And then you have smart drug release. This means the drug is being triggered by some external stimuli. So these are the smart dressing systems as well. So these are also powerful, they have strength, and you can have a tunable degradation like slow degradation or faster depending on the polymer, and good biocompatibility. So as we have discussed earlier, we have a list of polymers that we can select to fabricate our nanofibers, both from natural and synthetic. So we can choose either synthetic polymers or biopolymers. So the selection is very important because it will determine our final properties, or we have to design a nanofiber based system depending upon our end applications. So when you have got a list to decide from, it becomes tough. So there is always a game or challenge when we try to select among natural and synthetic polymers. Their properties are so much different. So I think every one of us is aware of the properties of natural and synthetic polymers. So natural ones are naturally occurring definitely, and they are more from biological sources, and they are biodegradable and biocompatible. On the other hand, the synthetic polymers are not biodegradable. This means they have limited applications, and they are also not biocompatible. So some synthetic polymers are biocompatible, however, they are not from renewable resources. As my talk is regarding the biomedical application of these biopolymeric nanofibers, so first of all I would like to talk about the diabetic patients. So as we know that for diabetic patients, one has to either swallow the pill or to inject the insulin inside his or her body. So that is the painful procedure. So instead of using these systems, we can use a nanofiber based patch attached to our skin that can release the insulin through our skin into our body. Then we don't have to inject ourselves with the insulin. This means this is more patient compliance product as compared to either oral drug or injections. On the other hand, let's suppose if a person has got inflammatory autoimmune disease, so this is a painful. So if you want to relieve the pain from your knees or joints, you have to take the pill. So when you take the pill, it goes inside your system, it dissolves, and then it reaches to that point where it is actually required. This means you have to put the extra effort or extra route, and many of these drugs go with the waste. This also means that you have to take extra drug than necessary. So if we can apply these nanofibers directly on these areas or these joints which are painful, we can have a controlled drug release or target drug release there, and the drug efficiency will be better. In other words, less amount of drug would be required. So similarly, if you have pain somewhere, instead of taking the pill orally, you can like directly apply the patch to get instant relief from pain. At National Textile University, our group is already working on various applications of biopolymeric nanofibers in medical and healthcare. For example, we have developed a wound dressing that can be applied to burn wounds. So where these dressings showed that they prevented the infection and they provided the drug in controlled manner, as well as, for example, for pain relief and antibacterial activity, and we checked that these dressings enhance the wound healing. So this means these are very suitable. Similarly, these nanofibers are being used for the cancer treatment. So various chemotherapy agents or hypothermia inducing agents or immunotherapy agents and gene therapy agents are entrapped within the nanofiber, and they are placed at cancer site where they release these agents and kill the cancers with apoptosis or other processes. So these are also being used for cancer treatment. Furthermore, these nanofibers are nowadays being utilized for various human issues. For example, women are prone to yeast infections, microbial infections down there. So there are various applications of these nanofibers. Among different available techniques, these are now being used for mucoadhesive, uh, you can say drug delivery system for vagina. So these are also being used for treating the vaginal cancer, ovary issues, and other issues as well. Another important aspect of these nanofibers are that they can be used as transdermal patch. So transdermal patches are normally applied on skin instead of swallowing the pill or taking tablet capsule, which becomes difficult for children and some old age persons. You just have to apply the patch on your skin. What the patch does is that it releases the drug which penetrates from your top layer of skin, that is epidermis, then towards dermis, and then subcutaneous fat. And after subcutaneous fat, the drug definitely reaches to the nervous system, which delivers the drug to the whole body. So you don't have to take the medicine. So this application is very important. For example, many of you might have been aware of the transdermal nicotine patches. So nowadays there are transdermal nicotine patches that are used to quit smoking. So they are very useful. You just have to apply the patch on your skin, so the nicotine will be released to your body, and you will not feel the desire to smoke. So this will prevent your lungs from damage from smoke and other notorious agents present inside the tobacco. So other applications apart from the biomedical application include the healthcare, for example, the cosmetic, the masks available in the market. So there are non-woven masks, and we can also develop nanofiber based masks. So this company, for example, has created nanofiber based masks for you can say refreshing skin, anti-aging skin, and these sort of products. So they are very popular in many countries, including Korea, other Asian countries. However, in Pakistan, they are not very much popular, but the trend is changing slowly, and female are more like the consumers of these sort of products. Another important aspect of these nanofibers is that their filtration efficiency. They are highly efficient in filtering various pollutants. So these nanofibers, they can be used to filter the microbes, viruses from the area. So there you can see application is increasing day by day because of their small size. Even they are smaller than the virus and microbes. So you can see that microbes cannot pass through the membrane of nanofibers. So you can get premium protection using these nanofibers. So there is another company that have used nanofiber membrane, and it has sandwiched the membrane among two other non-woven fabric surfaces, and they have checked against different viruses and microbes, and the air that becomes very clear after passing through these nanofibers. So we can say that these nanofibers have enormous amount of biomedical applications. Similarly, they can prevent you from COVID and other viruses and other transmittable diseases. Respected viewers, so whatever we have discussed so far is that the electrospun nanofibers are very easy to fabricate, and they have properties that are unmatchable with conventional polymers. So we can conclude that the nanofiber possess a great potential for biomedical application due to their high drug loading efficiency, ability to release the drug in a controlled or desirable manner, their biodegradability, biocompatibility, and other aspects. And they are better as compared to their counterparts or market products, and they are easy to fabricate. However, producing defect-free nanofibers with reproducible results is not that easy because there are so many parameters that you need to control precisely. For example, when we talk about polymer properties, we have molecular weight and solubility. Definitely, they are going to impact the final properties. Like if you are not in the optimum range of molecular weight, you will not get fibers. Similarly, the solubility of your polymer in that particular solvent is very important. And when we talk about polymer solution interactions, we have concentration, how much polymer you are going to add with respect to weight, its viscosity, like viscosity of the solution, conductivity, surface tension, pH, and one thing that is very important is the additive. If we are adding some pharmaceutical agent or nanoparticles or metallic uh, particles or anything like that, it will change all these properties in viscosity, conductivity, surface tension, pH. So it will interfere with the electrospinning process. So we have to fine tune. Even if like we can say we are adding 1% drug, so we have to check is viscosity, conductivity, what the addition of drug has done with our solution. So if we are increasing the drug content or decreasing the drug content, what effect it is having on our polymeric solution properties. And similarly, we have processing condition. For example, we can control the distance between needle and our collector. Then there is applied voltage like from 5 kV to 80 kV or 100 kilovolt. So we have feed rate. It also influences our you can say fiber formation and a needle diameter. Similarly, we have ambient parameters like what is the temperature and relative humidity inside the machine, and there are other parameters. For example, you can say the flow of air inside the machine. We can control that as well. So there are so many parameters to play on. So this is important for smooth electrospinning. At NTU, our research group is focused on biomedical applications like toxicity, wound dressings, and others. Filtration like water filtration, air filtration, energy like energy storage devices, cells, batteries, and others. So if you are willing to collaborate, we are always open, and we are more than willing to work with you. And we have facilities that can facilitate your research, your product development as well. So do visit us. So if you need some sort of any sort of other information, you can visit my profile at Google Scholars, like what kind of activities our group is interested in and what we are currently doing. So with this, I would like to thank the audience for their patience and for listening me out. And I am again thankful to the CEO Technobiz as well as Panther Ties Pakistan. So if you have any questions, the house is open for questions and answers. Furthermore, if there are any other queries, you can always email me at rajil.abid@ngu.edu.pk. So once again, thank you very much, students, stakeholders, industrialists, and listeners.
Thank you very much, Dr. Sharjil. Excellent presentation. I think before I let you go on this presentation, Light, can you turn on your webcam and also okay. So guys, before let's ask him, please ask any questions you have. Please post questions in the question box. Dr. Sharjil will address them at the end of all the presentation. You know the procedure, so I don't want to repeat again. Okay. Okay, Dr. Sharjil, tell us about your textile university. It's only about textiles, and what is happening in your university. Maybe you can share us more information about your university and your department. What kind of activities are happening, please?
So since 1959, National Textile University is mainly focused to develop human resource in Pakistan that can lead the country's security. So currently, if you go in any organization, especially textile related, it will be hard to find an organization without the graduate from National Textile University. So they are working excellently in R&D, in production, in marketing, merchandising, and any department you name. So the thing is that at NTU, we are majorly focused on textile, not only on conventional ones, but technical textiles as well as medical textiles, composite groups as well. We have extended our research areas as well as we are also providing, you can say, consultancies to various firms. So we are also focused on materials, polymers, as well as composite materials, nanoparticles, nanofibers. So the domain is, like you can say, increasing day by day, and we are trying to take the industry to the next level.
And you guys work with the government, private sector as well, in doing research, developing materials, polymer materials?
Yeah, basically we are a federal university and we are already in collaboration with more than 60 industrial partners. So any big company that you name, Crescent, Sapphire, Nishat, it is on our panel. So we are already taking out the projects that are in the interest of industry, and that is why we can say that you can join our together to discover about the opportunities for collaborative work.
So you do offer like an education program, PhD program, postgraduate programs too, right? Is it?
Yeah, exactly. PhD, we are offering PhD in textile engineering, in advanced material engineering, PhD in chemistry, and there are as well master's program, bachelor's program, fashion design, and many other.
And among these various textiles that you do conduct research in Pakistan, which area is very prominent, whether it's a medical side or whether it is technical textiles in filtrations?
Currently, you know that Pakistan has seen COVID as a blessing in disguise. the orders from all over the world, they are merged to Pakistan. So currently the industry is more focused towards the conventional textiles. We are trying to develop the product as per the customer's requirement, and we are increasing our production day by day. That is favorable for our country's GDP as well. And the technical aspect is that there are few industries that are, you can say, driving the market. They are producing their own products and then they are marketing it. So currently, the major focus is we are becoming customer driven. So the foreign companies, the big companies, Adidas, Nike, for example, they give us some sample and then we develop that and go for production.
And the research development, because the textile is an integral part of almost everybody's life, any research gets commercialized, patented and commercialized in locally or internationally? What's happening that side?
Yeah, definitely. Basically, our university is already working with you can say leading research intensive institutions of the world. For example, we have been working with Siri. Siri is the #1 institute of eye research and infection in the world. It is in Singapore. Then we are already in collaboration with the National University of Singapore, the University of Leeds, UK, France, Czech Republic, and many others. So we have a diverse team. So our faculty it is very dedicated. For example, recently one of our faculty member, Dr. Talha Hamdani, he has got a national patent regarding smart socks. The socks that can uh, tell you on your mobile how many calories you have burned all the day. So we have like triggered the research and then the response is very positive as well.
Super. Thank you very much for sharing the more information about national textile. And you also guys are in the standards development also for the country, in industrial standard.
Sorry, I couldn't hear
any standards developments, the quality standards for the products, and particularly on the textile related products. You guys, university involved in because on the national board or anything?
Basically, our university, as we are more related with the textile industry, so we have members that come and meet us regularly. You can say bi-monthly or after 3 months, 4 months. So they always guide us how they want to see the change in the students and what facilities should be here to conduct the research so that the industry can take benefit from it. But currently, the fact is that whenever we talk about international market, so there are some international standards like ISO, AATCC. So the customer says that I want this product with this ISO standard. So we have to check according to that. And currently we have some accredited labs at our university. So we have ISO certified labs like SGS and others, and you can get your test done accordingly. And many industries are already in collaboration with us. They send us samples, and the samples are valid all around the globe. The results are valid. Yeah.
Very nice. Thank you very much for sharing more information about in university. Keep doing good work. Thank you very much. We'll discuss if you have any questions in the Q&A session. Yeah? Please stand by. Yeah. Thank you. Okay, let's go to the next presentation. Our next presentation is focusing on the utilization of biopolymers for producing green elastomers. This presentation is given by Ms. Farja Manjur. She is also a researcher at the University of Engineering and Technology, Lahore, in Pakistan. Okay, let's invite Ms. Farja. Let me open her presentation file. Please stand by. Okay, get started.
Welcome everyone. My name is Firza Manzoor and I am doing MSc Polymer Engineering from University of Engineering and Technology, Lahore. Currently, I am working and doing research with my research team, including Dr. Yasser Qayyum and Dr. Farhan from UET. Today, I am going to present utilization of biopolymers for the production of green elastomers from the Forum of Polymer Research 2021. So let's start off with the topic. What is an elastomer? An elastomer is basically a combination of two materials. First is the matrix and second one is the filler. What make an elastomer to be green in nature is that for the green elastomers or bioelastomers or biorubber composites, it is mandatory to have one of them or both of them to be bioresourced and bio-based. It is just a simple representation of how biopolymers being incorporated in the elastomer or the rubber, forming green rubber by the increase in rubber filler interaction. They cause an increase in the mechanical properties. Why we require green elastomers? We require green elastomers because of specific reasons. First and foremost important reason is that we have to save petroleum resources as they are being finite in quantity and they are being continuously depleted because of the continuous production of synthetic based elastomers, synthetic based composites for today's application. So we have to protect the petroleum resources. Second one is the increasing growth rate of economy that produces a disastrous environmental pollution. We have to have such substitutes of synthetic material that can replace and can reduce the production. That can reduce the pollution. Third one is the high carbon footprint value of the synthetic material that can't be recycled, that can't be reused. We have to recycle them chemically or mechanically. That can give a high carbon footprint value. What is actually a carbon footprint? Carbon footprint is actually the production or the amount of carbon dioxide being released in the production or in the recycling of synthetically produced elastomers or composites. With these requirements, green elastomers have been raised in demand and scope in variant application areas, including automotive, tire industry, packaging, and medical. As I already discussed, that green elastomer is a combination of biopolymers and rubbers that constitutes and produce green elastomers with variant properties. So this is a general representation of the type of biopolymers being available or being commonly introduced and are being commonly used nowadays, and the type of elastomers in which we can incorporate and introduce a high amount of fillers, as rubbers are the materials that have a high free volume and they enable a large amount of additives and consume large amount of fillers in them to to have specific application to have specific properties for certain applications. So firstly, you can see from the left side, it is the biopolymers application. It's being the biopolymers classes, or you can say types of biopolymers that are being origin from animal, from industrial waste, from grains and plant and wood. Biopolymers or bioresource material that are being produced from the plant and wood or from the trees are lignin, cellulose, and natural fibers. These three are the materials that are being origin from trees or plants or wood actually. From the grain side, we have starch and polysaccharides that are being incorporated in the natural rubber mainly. And then we have from the from the animal based, we have chitin, chitin and gelatin that are being produced from the skin of animals. And fourth and the last one is the industrial bioproduct biopolymers that are named as biochar and eggshells that are being produced that are being the lowest and the cheapest biopolymers being available. It is actually the ash material that can be incorporated in the natural rubber or any type of rubber for specific or certain applications. The combination, and on the next side we have rubbers and elastomers for the pre-described applications as a tire industry majorly. we have certain rubbers available that are being used in tire industry or in automotives. First one is the natural rubber, second one is the styrene butadiene SPR rubber, nitrile butadiene rubber NBR, ethylene propylene diene monomer EPDM rubber, epoxide natural rubber and butadiene rubber. These all biopolymers can be incorporated in all of these rubbers as per your application or as per your demand. You can combine these two components with the addition of other additives to produce green elastomers that can have from these elastomers we can achieve dynamic mechanical properties, enhancement in mechanical properties, in thermal properties, and especially in the rheological properties. Biopolymers are the combination are the materials that are being origin from plant or animal. These are the true replacement of synthetic materials or non-renewable, non-biodegradable materials. Nowadays, industries and companies are moving towards to have a substitute and replacement of these non-renewable materials. So companies are moving towards bio-based or bio-sourced materials that are being origin from plant or animals. Basically, if we talk about the incorporation of biopolymers in the elastomers, then the first filler that is the most importantly being used in the rubber industry or tire industry is the carbon black. Carbon black is actually a material that is being produced from hydrocarbon cracking. Although it's not, this hydrocarbon cracking is a very energy intensive and it requires high energy for its production because for its production. Although in rubber industry it is the far and foremost important filler being used up till now, but because of some drawbacks of and the major drawback of carbon black is the non-renewability, people are now replacing it by biopolymers, as carbon black cause 2.5 tons of carbon dioxide production or release during the production of 1 ton of carbon black, as carbon black can cause 2.5 tons of carbon dioxide release. That is a very huge quantity. Or along with this, carbon black is carcinogenic to humans, as if we consume large amount of carbon black or large amount of filler or additive in the rubber because of the large free volume or in incorporating capacity of rubbers, we add in high concentration of carbon black that that can cause cancer or being carcinogenic to humans. A replacement of carbon black fillers. Biofillers and biopolymers are light in weight. They are easily available, and because of the easy availability, it is very important for the companies to have materials that are available to them in a very easy way. Along with this, natural fillers or bio-based fillers have a zero production cost, as as most of them are being produced from the biomass or from the waste of agriculture industry. I already brief about biopolymers classification. Let us have a detailed discussion on biopolymers. As you can see in this slide, biopolymers can be classified as plant-based and animal-based. Plant-based materials are cellulose, alginate, and lignin, and animal-based are chitin, collagen, silk, and keratin, DNA, and gelatin. The major and the most important thing in the biopolymers is that they are eco-friendly. They are biodegradable. Most of them are they are biodegradable and non and renewable. Because of these reasons, they are increasingly being used nowadays. But the major disadvantage of biopolymers, irrespective of its large number of advantages, is that they are hydrophilic in nature, and polymers in intrinsic ability is that they are hydrophobic in nature. Because of this hydrophilicity and hydrophobicity, the compatibility or the compatibilization of these bio-based polymers with the elastomers is a tricky is tricky, and is a major of is a point of discussion. But this issue could be overcome or could be minimized by the surface treatment of biopolymers with certain specific chemicals that can improve the compatibility of bio-based polymers with the with the elastomers. As you can see in the structure of cellulose, chitin, and lignin, they all have OH bond in the chemical structure that make it prone towards water. Because of this reason, they can easily absorb water and could reduce the mechanical properties of the end use product. For this reason, these biopolymers must be surface treated with certain chemicals or certain additives that could enhance the compatibilization of biopolymers with the elastomers to improve the mechanical properties. Now we'll describe about one of the biopolymer that I have used in my research project is named as gelatin. Gelatin is actually a proteinaceous biopolymer that is being derived from the hydrolysis process of collagen. What is collagen? Collagen is actually a triple helix structure that is being formed by the hydrogen bonding between the polypeptide chains that are being present in the amino chains. What is actually the structure of collagen is there are multiple amino chains that are being linked by polypeptide chains. These polypeptide chains are being joined by hydrogen bonding, and this structure is being aligned and organized in the form of fibrils. This is a very organized structure that is insoluble in water. For the collagen to be soluble in water, we have to heat up, we have to hydrolyze it in the presence of certain catalysts. What are the catalysts? Catalysts are acidic based or basic based. Depending on the catalyst, we will classify our collagen or basically gelatin into two classification. First is the type A gelatin and second one is the type B gelatin. If we produce acidic base hydrolysis process for the conversion of collagen to gelatin, this will be type A gelatin, and if we use basis hydrolysis process for the conversion of collagen to gelatin, this will be type B gelatin. So in gelatin, there is a sol gel temperature that is roughly about 35 degrees centigrade. This is the you can say this is the central point where the gelatin can be converted into gelatin solution or gelatin gel. If we heat up it above 35 degrees centigrade, the water molecules will be incorporated within the chains and will increase the free volume, and this gelatin will be converted into the solution. But at the same time, if we cool it below 35 degrees centigrade, these gelatin chains, or you can say the polypeptide chains that are being attached by hydrogen bonding, they will try to regain their triple helix structure and will form a gelatin gel. Rather than it being converted to the collagen, it will be an intermediate stage or reversible stage where the gelatin that has been hydrolyzed, it can only convert from gel to solution form or from solution to the gel form depending on the temperature. You can say that gelatin is actually a denaturalized form of collagen. Gelatin is a amorphous form of collagen that have loose structure and loose chains, while collagen have a structured and regular arrangement of polypeptide chains that make it a very excellent polymer for the to have such an elastomer with high mechanical properties. In the figure beneath, you can have the structure of gelatin. In this, you can see the peptide polypeptide chain structure bond, that is actually CNH-CH bond. It is a more open-ended structure that make gelatin a more amorphous material. For my research proposal, I have displayed one of the key or one of the reference recipe here, that is being the combination of rubber, cross-linking agent, filler, activator and accelerator. In this you can see I have added in 100% 100 phr actually of NBR, then the filler, that is the gelatin, is in 30% 30 phr. ZNO, stearic acid, TPPS are the accelerator and activators, added from 0.7 to 3 phr, and sulfur being the curing agent added in this formulation. From this formulation, I have expected to produce an elastomer with a tensile strength of 28 Newton per millimeter square, with hardness of 69 to 80 shore A, with the shear strength of 30 Newton per millimeter square, cross-link density of 8 into 10 to the power minus 4 mole per centimeter cube, and abrasion resistance for about 135%, with 135% volume loss. First methodology was the salinization of silica. As it was the first step, I used silica as a compatibilizer in this elastomeric formulation. As silica being the second most abundantly used and incorporated polymer or filler in the elastomers after carbon black, so I have selected silica, salinized silica, as a compatibilizer in this elastomer. Second step was the selection of gelatin that was gelatinized in the presence of water under specific temperature and time conditions. Third step was the melt blending of this gelatin and silica with NBR rubber and a specific curing agent, as I have described above, the accelerators, the activators and the curing agent in the internal mixer. Fourth step was the proper compounding and mixing of this internal mixer blend in the two roller mill to have proper dispersion and distribution. Fifth step was the compression molding of this elastomer to make sheets to have specific samples and for the testing purpose. And the last one was the testing and the comparison of the results. Are being concerned, the first graph representing the effect of filler concentration on the cross-link density of the elastomers. Let me first describe the top left block that showing the formulation. The controlled formulation is that formulation that possesses 0% pHR of filler, with the red line shows that formulations having gelatin and gelatin filler in various pHRs starting from 10 pHR to 50 pHR. Then there is a blue line shows the carbon black filled elastomer. Then pink, green and dark blue colored blocks shows the formulations having constant pHR of gelatin, that is being 30% pHR, and with increasing percentage of salinized silica from 3 to 4 pHR. As you can see, with increasing concentration of gelatin, the cross-link density goes on increasing in a constant in increasing way. This is because of the increasing concentration of gelatin reduce the absorption of solvent within the intermolecular chains of elastomer. This reduction in solvency or solubility or swelling cause increase in cross-link density or percentage cross-linking of the elastomer. Along with this, you can see that with the incorporation of salinized silica at constant pHR of gelatin, the cross-link density furthermore increase from 100 to 150. This might be because this might be because of the reason that salinized silica aid in the formation of crosslinks crosslinks in the elastomer. Irrespective of that, the carbon black possesses the highest cross-link density of 300 to 350 moles per meter cube. gelatin possess increasing trend in the cross-link density. Second graph represents the addition of filler with respect to the hardness of the blend. As this graph again shows that increasing trend with the increase in the concentration of gelatin, the hardness of the polymeric blend goes on increasing. As starting from 10 pHr to 50 pHr, the hardness goes from 50 to 80, show A. Along with this, you can also examine that increasing concentration of salinized silica acting as a compatibilizer again increase the number of cross-linking points that increase the hardness of the material, as increasing the cross-linking points of the material making it stiff and reduce elasticity that make it more harder as compared to the 0 pHr elastomer that possess 40 Shore hardness. You can see in the left graph, it is doing the representation of filler concentration on the tensile strength or the mechanical strength of the blend. This shows the same trend as the above mentioned graphs, as increasing the concentration of gelatin from 10 pHr to 30 pHr, the tensile strength goes on increasing from 8 to 15 megapascal. This is because of the reason that at 30 pHr the filler rubber interaction is excellent, that properly transfer the load from matrix to the reinforcement or the filler. But on increasing the gelatin concentration, the rubber increasing gelatin concentration or pHr from 30 to 50 pHr, the tensile strength goes on decreasing. This behavior might be because of the increase in filler bonding or filler agglomerates formation that reduce the transference of load from matrix to the filler. This reduces the tensile strength as it makes the elastomer more brittle and reduce the strength of the elastomer. Along with this, you can see the same trend as salinized silica represented in the cross-link density and hardness. As on increasing the salinized silica quantity, the tensile strength goes on increasing, but carbon black shows the highest cross-link density. Along with this, it shows the maximum tensile strength. Graph in this slide shows the factor filler concentration on the elongation and break as increasing the concentration of gelatin. Elongation and break was increasing, but on further increasing the concentration of gelatin, it reduced the elongation and break, as increasing concentration reduce the polymer rubber interaction and form agglomerates and making material more stiffer and brittle. Because of this, elasticity reduces, and this reason caused the elongation at break to be reduced up to a very high amount from 30 pHr to 50 pHr. But again, the salinized silica acting as a compatibilizer forms specific bonds with the rubber and the gelatin that improve the mechanical properties in cross-link density and hardness values. All these results of this research depicted and represented that increasing concentration of gelatin causes an increase in the mechanical properties and improvement in the mechanical and cross-link density performance of the elastomers. Along with this, these results shows that the comparable properties of mechanical behavior achieved by biopolymers as compared to synthetically made carbon black or any other filler. This wind up my presentation. Thank you.
Okay, thank you very much, Furja. It's a nice presentation on the green elastomers, even particularly using that biopolymers, at least in biopolymers. Guys, if you have any questions on this presentation, this topic, you can post these questions in the question box, and we address them at the end of the session. Okay, feel free to post a question, but again, please make sure that you are posting to the attention to the speaker name first. Yeah, thank you. Okay, let's move to the next presentation, the final presentation of today on this Pakistan Polymer Research Forum. Considerations on the cost-effective dispersion of calcium carbonate in polyurethane master batch. This presentation given by Ms. Isha Sharwani. She works for the J&J Polymer Industries based in Pakistan. Let's welcome Isha to make a presentation. Let me open her file.
Hi, I'm Isha Sharwani, and the topic of my presentation today is the considerations on the cost-effective dispersion of calcium carbonate in master batch, the polymer master batch, and the polymer that we will be specifically focusing on are PE and PP. And we'll be discussing what are the potential causes of the undispersed calcium carbonate, what are its effects, and what methods can we use to control this undispersion issue. So before moving into the problems that arise with the use of calcium carbonate, first we'll have a look at the reasons why the calcium carbonate has been used for a long time as a filler in the polymer compounds and why we are still using it in today's compound. So the first and the most important reason for the compounders or the manufacturer is that it lowers the cost of the overall compound. As you'll see that the cost of calcium carbonate filler is an average calcium carbonate filler is about less than 50% of the cost of your polymer resin. So you'll see with the use of the calcium carbonate as the filler, it depends on the quantity that you're using. The more you use, the lesser your overall cost of the compound will be. Secondly, it also improves the overall properties of the end product, that is your films, by replacing some of the plastic with your calcium carbonate. You're actually increasing the surface hardness of the products, especially the PP products, and you're also improving the heat resistance during the processing. Moreover, as compared to other fillers, the dispersion of calcium carbonate is relatively easier, and with more dispersion, you can get a better gloss and smoothness in your films. Another reason is that it prevents the black smoke from coming out. So when you're using a calcium carbonate as a filler, you're actually preventing secondary pollution because you're lowering the calorific and you're not producing any black smoke. Another very important reason for the manufacturer is that the availability of calcium carbonate is rather easier as compared to other fillers, because Earth's crust comprises of about 4% of the calcium carbonate. It is easily available all over the world, and the manufacturers all around the world can use it in their processing and the manufacturing and reduce the cost of the product while improving their properties. Calcium carbonate is being used in the manufacturing of polymer master batch and how much it should be used. So the amount of the calcium carbonate that can be used is up to 80%. It totally depends on the end product properties that you are striving to achieve. The more calcium carbonate you'll be using, the less transparent films you'll be getting, because transparency is actually the properties that you'll be achieving by using the polymers, especially LDPE, and it's not the property of the calcium carbonate filler. So the more calcium carbonate filler you'll be using in your master batch, the less transparent and more of the whitish and opaque films you'll be getting. And other properties that are affected other than the transparency are the flexibility of the films. Since we know that calcium carbonate isn't flexible, it's rather hard. So the more calcium carbonate filler we're using in our master batch, the less flexible films we'll be getting. And so you're paying the cost of the lowering of the properties when you're making low cost master batch. But for the end products that are to be used in a very low-grade applications such as making a garbage bag or something like that, you can easily use up to 80% of the calcium carbonate to make a low-quality master batch that can be used fairly well in your application while reducing the cost at the same time. However, when you are striving to achieve the films which are more flexible, which are more transparent, you have to reduce the amount of the calcium carbonate that you're using. These are the calcium carbonate used as a filler in the master batch processing. The measurement of these properties is necessary because now these properties of the calcium carbonate not just affect the end product but also the processing of our master batch. For example, while using calcium carbonate of different particle sizes, the processing, the mixing, the resin are all different with the different size of the particle size of the calcium carbonate. There is a general rule that if you have a small size calcium carbonate, it will probably have a high oil absorption and you have to use more of the resin as compared to while using larger particle size of the calcium carbonate. So for the choice of the resin for the formulation, you'll be considering not just quality of your calcium carbonate, you have to take into consideration its properties such as the particle size and the oil absorption. So these properties and other properties of the calcium carbonate are necessary because you're using it in a larger amount, like up to 80%. So it will surely have a very large impact on your end product and your processing. And all these properties can be measured using the relevant equipment and relevant standards. Like for example, the whiteness can be measured using spectrophotometer or colorimeter, and the impurities can be checked using the titrations. Particle size can be checked via particle size analyzer. All these tests are necessary and can be done inside the laboratory. Now we're coming to the main topic of our presentation, which is the problems that occur when we're using the calcium carbonate filler. What are the reasons for these problems and the potential solutions that can be applied in a cost-effective way to reduce the problems with the calcium carbonate filler? The first problem that occurs is the blocking of the net. The blocking of the net actually means that when you're manufacturing the calcium carbonate filler master batch, you're using extruders and there are sieves at the end of the extruder, and our master batch has to pass through the sieves during the end stages of our extrusion process. So if the calcium carbonate you're using doesn't have a proper uniform texture, or you're not using the right quantity or the right type of lubricant, or if your material is humid or damp, all these reasons can cause blocking of the net or the sieves in the extrusion process. So this is a problem that can occur even during the processing stages, and the potential solution to these problems, to this problem and the reasons can be by selecting a very high standard calcium carbonate, selecting a calcium carbonate that has a uniform texture. Well, you can see that the calcium carbonate is actually available in so many forms and so many types, and it's really important to choose the right type of the calcium carbonate, the right texture, the right color, the right purity, and the right particle size of the calcium carbonate to cope with all these problems. And secondly, you have to either replace the type of the lubricant you're using, or you have to adjust the ratio or the amount of the lubricant you're using. And generally, we use oils and waxes as the lubricants in making the master batches. It's really important to adjust the ratios in the overall formulation and to select the right type of the lubricant. Thirdly, it's really important to dry the raw material before using, and if the raw material isn't dry, you're either going to get the material stuck in the sieves, or you're going to get other issues in your blown film, such as the fisheye. Another problem that occurs is the blooming of the film surface. Well, the blooming means that the surface has some low concentration of the bulk material, like the plasticizer, and it occurs due to the high surface energy. And the practical reasons behind the blooming of the film is can be that you're actually using the wrong type of film master batch for the wrong type of resin. For example, that you have manufactured a polymer master batch for HDPE, and you're using it for LDPE resin. So there will be a difference in the melting points of both the master batch and the resin, and you'll get the high melting material blooms to the surface of this film. And another reason can be that you're not properly formulating your master batch, and the dispersion of the raw material isn't good because of the formulation that you're using. Or the third reason can be that the temperature of the extruder is not in place, because you might be using the temperatures that you were using for making an LDPE master batch for your HDPE master batch. There's a difference between the melting points of both the resins. HDPE melts at a higher temperature as compared to the LDPE. So if you're using same temperatures for both the materials, you're gonna get the problem of mixing and dispersion and blooming on the surface of the material. So the potential solutions can be that you should be using the right master batch for the right resin, adjust your formulation, adjust the temperature, and you can also increase the extruder compression ratio if you have eradicated all the above issues and all the above problems, but you're still getting a surface that is blooming. You can check the extrusion compression ratio, because if the extruder's compression ratio is not in place, you're not getting a proper dispersion, and that can also cause a surface blooming of the film. Other problems that occur include the film shear strength being impaired. Well, this problem is more relevant to the blown film, because if the inflation ratio or the drafting ratio is not proper, not in place, so you might get a balloon that you might get a film that has an impaired film tear strength and improper and an impaired tear strength. So it's important to adjust the velocity, to adjust the ratio of the wind-up velocity and the exit velocity of the filament, as well as the inflation ratio of your blown film. Another problem that is very common and that is related to your raw material and can be highly dependent on your calcium carbonate is the fish eyes that occur in your blown film. The fish eyes occur because or that you might be using calcium carbonate that has been left in a bad condition for a long time, and the material has got moisture in it, and this leads to the existence of the fish eyes. So it's really important in these conditions to check if your material is moist or not. In case it has got some moisture, you should be reducing the loading of your material, because the lower is the loading rate of your material, the more time it will get dried inside the extrusion process. You can also use industrial dryers, and desiccants is solution to the moisture, but it cannot be used over 1.5% of the total compound, because it will be increasing the cost of your compound, and there will be no point of using a filler master batch in that case. So the major issues that occur are the dispersion issues. These issues can occur because of bad processing conditions, bad feeding conditions, but we'll be focusing on the dispersion issues that occur while we're using a bad calcium carbonate type or granules, and which are not filtered fully, and what effects they might be giving to your final film. One of the major dispersion issues is the gel formation. It is major because it is very likely to occur and it is difficult to predict and hence to solve as well. And there are different types of gels that can be present in your film, such as unmelted gel, unmixed gel, cross-linked polymer, oxidized materials. You can get impurities from, impurities from a foreign environment can be caught in your material. You can get contamination, especially when you're using a recycled material. And there can be multiple reasons behind these, such as like humidity, um, impurities, a poor dye or extruder design, dispersion issues. So we'll be looking at these gel types individually and know what the issues behind these gel types are and what can be possibly done. So we'll be first looking at the thermally crossing gels and the highly oxidized gels. These types of gels are usually generated in the stagnant regions of the extruded screws and the transfer lines. And the most common regions for the degradation are the slide radii in the metering section and the deep flues of the Madoc style mixers. For our consideration, we'll be looking at the slide radii, which is a very common phase of the creation of these types of gels. So the slide radii in the medium section of the screw should be relatively large to the local channel depth, because if the radii are small, eddies can occur. These eddies are actually called the Moffat eddies, and these eddies can occur, which can create regions with long residence times. And these regions can act as a location where the resin can degrade because of staying for a longer period of time. So the sharp corners are the places where these Moffat eddies are created as secondary flows. And simple process subset can knock the degradation off of the flights and into the main flow, which will eventually create effects in the film product. To cope with these types of gels, it is recommended that the screw, which is the owner of the extruder, should request the rebuilder to maintain the flight radii size, especially for a first-time rebuild with a new fabricator, because when the screw is retained to the plant after rebuilding, the screw should be inspected for flaws, including the flight radii side, because before the screw is placed into the storage. Because these types of gels are explicitly related to the screw type, and the design of the extruder. And so the only method to reduce these types of flaws is properly designed screws. Because even if you use antioxidants, you cannot use it for a longer period of time, because these gels are actually created when the resin has to stay for quite a large period of time, that even these antioxidants don't work enough, and this will create actually an increase in the cost of your overall product. The unmixed or entangled gels, and this problem is more common with polyethylene resins. These unmixed gels are typically high molecular weight polymer chains that are entangled and are difficult to disperse during the extrusion process. And these gels exit the dye as a molten material and then solidify first during the cooling process and create appearance of these gels. In order to analyze these types of gels and differentiate these gels with the other type of gels, we use a hot stage microscope, where the portion of the film that has a gel is positioned between the specimen slide and a glass slide over. Then the gel is melted by increasing the temperature, and when you reduce the temperature, the gels will recrystallize. Upon reheating, the gels will remelt, and when the cover slip is pressed and moved using a dental tool, the gel will not appear when cooled. So it means that the stress applied by the dental tool has disentangled these chains. So now that you have identified that these are the unmixed gels, you can remove them in the extruder by increasing the stress level in the Madoc mixer. Other than that, the stress level can be increased by decreasing the clearance of the mixing flight. So the stress level required to disperse these unmixed gels will depend on the resin and the level of chain entanglement. And it's actually advisable that the mixing flight should be adjusted. And so this is also the problem that is highly related to the design of the extruder. So what do we summarize from this is that we should be using a high quality calcium carbonate even if we are using it as a filler, and our goal is to reduce the cost of our product. We should be using a high quality filler because the quality of the filler will be affecting your overall processing as well as your end product. If your calcium carbonate, as we have seen before, if your calcium carbonate doesn't have a proper surface, it will cause the end product to have poor tear strength and poor surface as well, and it will cause issues in the processing like the blocking of the nut. So it's really important to use a high quality calcium carbonate, and within the quality comes the particle size of the calcium carbonate, which will affect the overall appearance of your film as well as your processing. Secondly, we have noticed that using the correct amount of the filler is also really important, because the more filler you use, the lower will the properties or appearance of your end product, especially the films, will be. Using the correct procedure is really important while manufacturing the calcium carbonate filled master batches. As we have seen, if the procedure is not correct, and if you're not using the right parameters, will be getting problems during the processing and in your end product. So it's really important to use the right properties of the calcium carbonate, because if let's say if your calcium carbonate doesn't has the lowest amount of impurities, it will cause issues while you're passing it through the extruder, and it will cause contamination in the film. And if you're not using the right whiteness of the calcium carbonate, you'll be getting the films that are not white enough and that are yellower in appearance, and it will also reduce the overall cost of your product. So at the end, it's also really important to use the correct machinery, to use an updated and free of flaws machinery to manufacture your filler master batch, because at the end of the day, our goal is to get a product with lowest cost but with high quality. So you cannot um, get a good quality product and with a reduced cost if you're not taking into consideration all these points. I hope this clears the importance of choosing the right quality of the procedure as well as your filler, while to reduce the dispersion issues of the calcium carbonate in making your filler master batch. This topic is really important, and it might seem a very minor topic of no interest, but it is really important because, for example, the recycled plastics have been used in the cars for over a decade. However, you may not see them because they are located below the interior or inside of the vehicle structure. For example, in terms of the total vehicle weight, they usually do not occupy much plastic waste, and it can be a threat to many people. But for manufacturers, this is a source of recycling their raw materials. Now, along with the pressure of the media mass and the change in the people's awareness of the environment, their ideas are further confirmed. However, they not only use the recycled materials but also combining with the calcium carbonate master batch on the resin additives and compounds, especially and compounds. When the quality of the recycled material is increasingly improved, manufacturers started to utilize them more. In some places, it is easier to see on vehicles. And as we know that the manufacturers are using more of the calcium carbonate master batch, because the vehicle weight is one of the important factors that manufacturers are interested in, because the lighter your car is, the less energy it consumes. Hence the manufacturers are looking for the lighter material, that is light enough but still meets the production techniques for the car. And in this case, the recycled plastic and using it along with the calcium carbonate is an innovation that is being used and that will be used in the future as well. So with the use of polyethylene calcium carbonate into the car bodies or electric insulating parts, it has confirmed the use of the calcium carbonate master batch in the future in high-end applications. And we cannot use it properly if we do not know how to cope with the issues that occur with the usage of the calcium carbonate. And I hope this presentation gives you an insight to how to cope with these issues and to know what kind of issues actually occur while you're manufacturing the master batch. Thank you from my side.
Oh, thanks a lot, Isha. It's an excellent presentation on the problems and the dispersion, and probably that you how to overcome the problems, and you mentioned very nicely. Thank you very much. Let's okay, we are almost done with the presentations. Okay, if you have any comments on this presentation, I would like to in the question box. Okay, may I invite all the speakers to open our webcam. Okay, and so we get started. We have received a couple of questions already. We address them one by one. Can you please open your webcams, please? Okay. Firjan and Zumar. Okay. Dr. Ashir, could you please open your webcam too? Yeah. Okay, good. Okay, everybody sees my screen. Yeah. Okay, this is the first question to Dr. Ashir.
Well, in order to increase the stiffness properties, nanofillers can be a very good option. At the moment, I would just like to answer this question by saying that we are working within our department to increase the overall mechanical properties of biopolymers by utilizing the various nanofillers. The biopolymer that we are using at the moment is PBAT, and along with it, we are using TPS. So this can be an option, but you do need to realize that nanofillers, once they have to be incorporated within any polymer, whether we're talking about biopolymer, you have to first of all make sure that there is good compatibility between the type of nanofiller that you're using and the end polymer that you are trying to target. Now, there are various ways in which you can surface modify your nanofillers, but there is a precaution that you need to also follow. The method of modification that you would adopt, if it alters the overall food acceptability of your nanofiller, then you will face quite a lot of huge challenges. So what I would normally suggest to the industry in that regard is try to adopt the techniques that are based upon mechanical modification of your filler. For example, you can use ultrasonication, you can use microwave exposure of your filler, as a result of which you can then ensure good dispersion and distribution, about which I talked about in detail, as a result of which you can get good mechanical properties. I hope I have answered the question.
Thank you, Dr. Ashir. Okay, there's one more for you.
Yeah, for biomedical applications, once again, in order to enhance the properties, you have to look for two of the techniques. You do need to keep in mind that I'm not in favor of chemical modification, especially once we are talking about biomedical or packaging applications. Ultrasonication can give you very good options in terms of eliminating the agglomerates. Okay, but then once you are trying to make sure that how those polymer solutions are being dried out, that becomes a really important criteria. If you are just going to leave them in a drying oven, then all of the agglomerates that you have broken down with the help of sonication or even by exposure to microwaves, those will try to reassemble. The clay layers will try to reassemble once again. So it totally depends upon how you are going to further on make sure that your polymer solution is dried out properly by making sure you either use centrifugation or you try to make sure that you get as quick elimination of the solvent as possible so that your agglomerates don't form once again. If you just leave them overnight, try to dry them, in the end final product that you will achieve, you will once again see quite a lot of agglomerates. If you have carried out the scanning electron microscope analysis of polymers, in it you are always asked to make sure that you try to use as bare minimum of a sample that has been dispersed in any solvent or any dispersant so that you don't see any agglomerates in the SEM. So my suggestion would be to try to use ultrasonication or exposure to microwaves, and then try to make sure that you eliminate whatever solvent you are using or moisture as quickly as possible by centrifugation, or there are other rapid quick drying techniques that are available, as a result of which you can eliminate most of the moisture or solvent very quickly. Okay, any other question?
That's all for you, Dr. Isir. Let me go to the next question to the Ms. Juma. This for you.
The question is why you are using MWCNT instead of SWCNT. First of all, SWCNTs are mechanically weaker than MWCNT. And second thing, when it comes to bulk process, the bulk process of MWCNT is easier as compared to SWCNT because it do not require the catalyst and it's moreover it's cost effective. Moreover, MWCNTs are mechanically strong, so can uh, they can have a longer lifespan during application. And when you yield on industrial scale, SWCNT provides only a 72 to 80% yield. But when it comes to MWCNT, it can give you a yield up to 98%. And purity in SWCNT is achieved with a huge difficulty, and whereas MWCNT are processed with high purity. Moreover, they are cost effective. That's why we use MWCNT instead of SWCNT.
Thank you, Zumar. So one more question. Oh, this is for Farja. Farja, you can open your audio. Yeah, your webcam has some problem. Go for it. Just with audio. Yeah.
The question is, have you looked in the commercial availability of these biopolymers in Pakistan and cost effectiveness compared to traditional materials which cause pollution? Regarding these biopolymers, I am currently working on this in my industry too. They are easily available. You can approach them easily because gelatin is an abundantly available material too. And from the cost perspective, if you are going for biopolymers that are being generated from the waste, they cost 0% value. For this reason, you can have those biopolymers that are being generated from the waste and could incorporate into your rubber or an elastomers to have a value-added material and value-added product. So the initial cost will be zero for the biopolymers if you are using those biopolymers that are being generated from the waste. But as Yasser have already told you that if you are going for PLAs or other biopolymers that are actually the polymers in nature, they will cost high. But for that reason, you can incorporate in them too, because the industries are going towards the biopolymers and because of the recyclability issue. So if you are going to have recyclable material or bio-based material, you must have to compromise on the cost. Any other question?
Okay, I'll get back to you, Fdir. Let me go through other questions. Thank you, Fdir. Okay, this is for Sharjil. Dr. Sharjil.
Yeah, so the question is, can you comment on nanofiber market in Pakistan? So currently, the nanofiber market is very, you can say, promising, but not yet explored. Because I have seen only two products currently available in Pakistan. One is the nanoclo mask that has been developed by Mehran University of Engineering and Technology. And the other one that has been developed by our university, that is also a mask that can prevent you from COVID and other infections. So what they offer is that the mask that we have developed, it can be used for almost 20 washes. So you can say that it is promoting the sustainability, the same mask we are using day by day instead of the single-use mask, as Dr. Yasser Qiyum already mentioned. So the single-use masks are very, you can say, pollution-causing materials nowadays. So currently the market is open and it is a very, you can say, interesting market because its applications are so much. However, apart from Pakistan, in developing countries, there are some products that are commercially available. However, in Pakistan, its market is not fully developed yet.
Okay, thank you, Dr. Sharjil. The next question is for Dr. Ms. Jumar. This question for you.
Question is, why did you prefer polythiophene over polyaniline? First of all, polyaniline has an energy band gap of 3.8 and its band gap falls to only 2.9 electron volts when you mix MWCNT with it, whereas polythiophene has the energy band gap of 2.08, which is much more less than polyaniline if even after mixing MWCNT with it. And with mixing CNT with polythiophene, its band gap goes up to 1.1 electron volt, depending upon the concentration of MWCNT used. So its conductivity is better than polyaniline. That's why we use polythiophene.
Thank you, Jumar. So another question. This is for Farja. It's for you.
So what makes gelatin compatibilized with rubber? As I already discussed, that first factor is I have introduced gelatin in NBR rubber. NBR stands for nitrile butadiene rubber that have acrylonitrile bond compound or present in it. That makes it a polar rubber. Along with this, gelatin is also a polar material that makes polar interaction increase. Furthermore, for better interaction, for better compatibilization, I have added in silica that is being surface treated with silicized material that increases its compatibility and bond strength. These two factors make the gelatin to be compatibilized with rubber to have high mechanical properties.
Thank you all. That's all the questions we have. We're almost done with this, Pakistan Polymer Research Forum. Before we end this program, I'd like to ask you one by one, maybe a thank you note to the audience, okay, welcoming them to following you or contacting you in the future. May I ask, start with Dr. Yasser? Any remarks to the audience, please?
Thanks everyone for attending today's session. It was a really informative session, and I hope in the future we can have more sessions like this. We at Department of Polymer and Process Engineering always welcome interaction with other faculty members and from the industry. So we are available for any collaboration in terms of research advancement or your product development. And I would also like to thank Technobase for arranging this session, and I hope they can now introduce more sessions like this that can then be broadened into typical areas, okay, that can be related to, for example, for smart polymers, we can have a session. For packaging, we can have a typical session. Then it will become much more easier for us to also contact the students and also we can then target the industry more effectively. I know initially we should continue with polymer so that we can get more and more participants, but in the future it will be much more beneficial if we can target specific areas, and then for those areas we can then promote the research forum and then try to get more audience for particular areas. My suggestion would be we can move into recycling and packaging, into composites, into smart polymers, into energy areas. So these are the various areas we can then hopefully target, and not forgetting Hamid's areas of elastomers. Okay, that is also important. So we can also target that area too.
But I totally agree with you, Dr. Ashir, that of course it's a first edition of that what we planned this polymer research. We'll be addressing focus subjects in the future and more frequently. Okay, and we take one. I totally agree. I take your suggestion, and we add definitely the recycling, packaging. I think is as you know, circular economy is in a buzzing word. Everybody wants to. You're talking about it, and also I think manufacturers feel the responsibility about it. So I think there are a lot we can address it. Totally agree with you. Thank you very much for your suggestion. I appreciate it. Yeah.
Thanks.
Okay. Dr. Sharjil, would you like to share a few remarks?
First of all, I would like to thank you, Mr. Piram, and then Mr. Hamid for such an exciting event. So the talk of Dr. Yasser was very interesting as well. And whatever he said, it is the need of the hour, because now it is time for Pakistan to go circular. Because we are a textile and agriculture based economy, and the textile is related with the enormous amount of waste generation, and if we are not going towards sustainability or recycling, so we are going to collapse. So our industries, they are trying to produce, and they are trying to become more sustainable. However, the end product, they are not yet sustainable, because polyester, it is not biodegradable, and it is one of the preferred fibers for the textile sector. And there are some companies that have developed some advanced technologies to recycle polyester using biotechnology as well. So we need to work together with experts like Dr. Yasser and Mr. Hamid and others, and everyone is welcome, because it is not about a single field. So when there will be more minds working towards a single goal, we can achieve it. And this is not for us, for our research, this is for the country and for our upcoming generation. So once again, I would like to thank all and thank the attendees for listening.
Thank you, Dr. Sharjil, with your well said statement for future, for our country. Fantastic. I agree with you. Totally agree with you. We continue to work on these agendas on a regular basis. Thank you very much. May I ask young researchers, Jumar, what do you think about it? What are your comments, remarks to the audience?
First of all, I would like to thank the audience and pay my gratitude to you and Mr. Hamid for conducting such a super session. And secondly, I would like to acknowledge this work to my supervisor, Dr. Umar Mahmood, and Dr. Yasir Kirongi, along with the Department of Polymer and Process Engineering. They made me able to do this project successfully. And last but not the least, the session was very informative, and looking forward to more such sessions.
Sure. Thanks, Jumar. Farja, I'd like to share some remarks.
First of all, I would like to thank you and Mr. Hamid for arranging such a wonderful platform for new researchers to present and to communicate our research work to other participants and other audience. And I would like to give my gratitude to Mr. Yasser. Sir Yasser, he gave me a chance to have such a good research to be working on. And last but not the least, I would like to thank TechnoBiz for arranging such platform for the new researchers. Thank you.
Thank you very much. Okay, we're almost done. Hamid, I would like to invite you to give a thank you remarks to all, including speakers, please.
Yes, I would definitely like to thank all the presenters and especially the participants, the attendants, who spared their time for today's event. As I already told you that this is one of its kind event in Pakistan. I don't think any such activity has happened before in the past. So this was my main goal, my main attempt to promote such things here in Pakistan. Just like Dr. Shajil said, this is not about us. This is about our country and for our upcoming generation. So this was exactly my aim as well. So this is what I had back in my mind while I was preparing for this event, while I was coordinating with Payam for this event. So anyways, today's event was more than exceptional for me. However, I have noticed a few gray areas or some like low points, which I would definitely try to focus in collaboration with Pam to eliminate those low points in the next event. So thank you very much, all of you. Would especially like to thank Mr. Pam. I met him first time in 2018, I guess, in Indonesia, and ever since he has been in contact with me, and he's very energetic person, very self-motivated person, self-driven person for such activities in polymer field. And it would not be justified if I do not thank Dr. Yasir Qayyum for his help throughout this activity for me. I mean, without his help, I don't think I would be able to manage such an event, because this is one of its kind event and a lot of people were reluctant to participate. I don't know the reason why they were reluctant, but Dr. Yasir came ahead. He's a long time friend of mine, so he came ahead and helped me a lot in this matter. So I would like to say a special thanks to him. And once again, thanks to all the participants, thanks to all the attendants. And I would like to especially say to the attendants of today's event that you people can approach us directly or via Mr. Pam for any kind of technical collaboration, for any kind of technical discussion, because it's all about sharing our research. It's all about sharing our working with each other so that we can mutually progress is in a win-win situation. If we keep our research working to ourselves, not only we would not learn, but we would not also be participating in the well-being of our society, because society is our local society here in Pakistan, or if we are residing in a certain city, we say I'll only share with my city fellows or my country fellows. No, it is not like that. It is the world is now a global village. We have to interact with everyone, not only for our own learning, but to promote the things we have done, we have learned. So it's all about that. So I hope we all stay connected with each other and do more such events, as Pam has already given a tentative, I think not tentative, but the fixed date for the next event, which is in May next year. So we'll make this event even a bigger and better one. Thank you very much.
Thank you, Hamid. I echo totally what you said. Okay, there's not much to add, but just want to add, this is a first step to bring the polymer research happening in Pakistan to the to publicize, to make the research to be informed to the global community. And on behalf of Technobase, I thank you all speakers and participants, of course, my friend Hamid. Okay, so we see each other in our next schedule, okay, upcoming schedule in May 2022 on the 28th. We will make it better, as Hamid said. Okay, there's always first step. We learn lessons and we take it forward. I thank you all once again, and I see you in the next session, which will be happen on the 28th May. Keep in touch and follow us through our Technobase platform. Anything we can assist you, you can write to us or any of the speakers or Hamid. Okay, thank you all. Bye bye for now.
Thank you.
Thank you.